continuous formations with Cation. This webinar will be using Grasshopper and Rhino, and then Blender for some visualization along with Photoshop. And yeah, so Alan is currently the lead computational designer at KPF, and he's an MArch from California College of the Arts. Alan is computational designer, artist, and educator in New York City, currently as lead computational designer at KPF. His work focuses on parametric architecture, complex geometry, sustainability, robotics, 3D printing, and simulating natural behavior systems. Alan utilizes his expertise in generative and computational design to take an exceptional approach, experimental approach to the design process, where he imagines speculative futures and incorporates advanced digital fabrication technology and technologies to realize complexity. Actually, that last part is wrong. That's my mistake. But you were previously computational design specialist at Unedited Architects, and are teaching at the City College of New York. You are still teaching there, yeah?
Yep, I'm teaching a graduate MArch studio there.
Seems this old sentence here snuck its way in.
Oh yeah, it happens. Well,
We'll just
it was only a month.
We'll pretend you're working at both places, like Superman.
Yeah, moonlighting over here.
Yeah. Okay, so is there a link down? Nope. Whenever there's a link, we'll give it to you. There's not a link right now.
Yep, making the link. Cool.
So,
yeah,
possible. For some reason, I received the link from my session. I received a link to Metaverse Inception. Anyway,
so I'll put a link in the chat.
Yeah.
Okay. So try to click that link, see if you're able to access those files.
Oh, you have to switch to everyone.
Oh, my bad.
Yeah.
Committed this mistake.
There you go. So yeah, that link there is where Alan will be working from, and he'll be, I guess, saving to there as he goes. So if you fall behind, you can grab stuff from there. Okay, well, yeah, I'll be here the whole time, and I'll leave it to you. And yeah.
Sounds good. Thank you for the introduction. So this should be fun. I think so. Some things that we're going to do today. Basically, we're going to go through the process of creating meshes, relaxing meshes in Kangaroo. Probably a very simple process for that. Then we're going to be doing the minimal surface generator. So this is probably going to be the most involved part of the workshop. So we get that out of the way with the first probably 3/4 of the workshop. Then we will be doing a pufferfish box morph panelization strategy, like on the minimal surfaces that we're developing. And then we'll be looking at Blender and seeing some render techniques. So yeah, just let me know if that link doesn't work in the chat. If I don't hear anything, then I'm going to assume it works. Cool. So I'm just going to turn my video off for this to save some bandwidth. Awesome, link works. Good. And there's people from all over. Welcome everyone. It's so cool. See a fellow Brooklyn person. I'm in Brooklyn right now too. Okay. Awesome. More Brooklyn. Cool. So this is the folder that I've shared. So I'm going to be working out of this folder. There is a 2022 design morphing example file here for continuous formations. So I'm just going to go ahead and click that open. Oh, also worked at KPF. Very cool. Welcome. Architecture is a small world. Okay, so when you open this file, this is what you should be seeing. So should be a few meshes in here, a couple of sub D objects, and then some panel objects. These ones I can go ahead and turn off. So turn off the panel. The first thing we're going to do, because we're going to be looking at relaxing meshes using kangaroo techniques, we can look at a few of these meshes here and see about smoothing them. So the first thing that I might do, so these are examples. So these are ones that I've already created. If I click on this, so I don't have mesh wires shown right now. So let me just turn that on real quick. So you can see better. So yeah, it's showing the bold faces. So when you're looking at a mesh, just quickly describing the display settings, unless you've changed the settings in your Rhino viewport, what they do is anything that's a naked or unwelded mesh edge. So unwelded being that each one of these faces has a point associated with it. It will show up as a bold line, but anything that is a mesh edge that is welded will show up thin. So if you turn mesh wires off, like I just did, turn on, it will not show the wires, but it will show the boundaries. So anything that's considered like the outside of a mesh and it doesn't have anything connected to it, that is considered a naked mesh boundary. So I'll turn wires on really quick. So let's just create one of these real quick. I can go through the process of, how I might create something like this. So I'll turn off this layer and I'll just turn off these layers and make another layer here. Just call this mesh example 3. And I'll click into that. So the first thing I can do is I can say mesh box. So mesh box, it's going to ask for a corner point. For faces, you can change the count of the faces that you give it. For now, I can just leave this at 1, 1, 1. I'm working in the units of meters, by the way, so all units are in meters. It doesn't necessarily matter, but it could be helpful for just understanding what you're doing. So I'm going to make this box, and let's just say I'll make it 5 meters by 5 meters by 5 meters. So yeah, I mean, that's really all there is to creating a mesh. So what this is giving us is it's giving us a box that each face is one face to the box. So if I wanted to make it with more faces, I could do that. Or I could take this, I could make a copy of this, and I could use the command called subdivide. And that will subdivide each face and split it into 2 faces. So, well, really it makes it into four faces because you're splitting it in one axis and then another axis. So each face gets split in half, which ends up giving you 4 extra faces. So you could run subdivide a couple times. If I redid that command, it's going to do the same thing for the next face. I don't necessarily need it that subdivided. So one thing that's cool about working with mesh geometry is that you can actually, like there are commands where I can, scale things, I can move things around with commands, but you could also have helpful keyboard shortcuts I can press Control and Shift and hold that, and then left mouse click and actually grab objects about the mesh. Like faces, I can do the same thing for edges. So I can select edge loops, and you can also select vertices. And if you have the gumball enabled, whenever you select vertices, edges, or faces, you can move those around. So I can move around a vertex any way that I want. I could take the face and I could move the face up and down if I needed to. You can also give it a specific distance if you want, just typing in if you just click on the gumball property. So you can do a lot of things. So another thing that you could do is if I have this selected, if you see this blue arrow that's, talking about, that's basically the Z vector in my file, you can click this little circle thing, this sphere object here. I don't know what they call it, but you can click that and actually extrude your face. So now we've actually made a mesh with an extrusion. So if I do that, I could give it even a specific value. Like maybe I want this to be 2 meters and extrude it 2 meters. So a cool thing is I can do that. I could take this. You can use the gumball to even scale your mesh face if you want. You can also delete it. So if I want to delete that face, so if I look at my example 1, this is from, basically I created this from extruding the faces and deleting them. So we could just recreate that really quickly by doing that. So you got to make sure that you're on the sphere. I'm not going to care about dimensions right now. You can, but if you don't want to, you don't necessarily have to. Oh, and then also deleting them. So I'll just go ahead and delete the rest of these. So this is a super quick and helpful way to basically model with mesh geometry in Rhino. So this is something I do a lot. A lot of the processes, a lot of the sub-D workflows also work the same way. So kind of a connection. We'll talk a little bit about, differences between meshes and sub-Ds. But a sub-D is basically using a mathematical kind of interpolation of, but the geometry itself is kind of, the topology is set up the way that a mesh works. So that's kind of the biggest connection between sub-D and meshes is you can kind of go back and forth between them. So just to show you real quick, if I were to use a command to sub-D, so I can make a sub-D from this mesh object just by doing that. And then I press enter. I'll move this off to the side, the sub-D I just created. But you can see the sub-D is using the same amount of faces as our mesh object is here. So it's basically just created a smooth representation. The cool thing about this is you can also then turn this into a NURBS object if you need to do that. So I can use a command that is to NURBS. And then basically now create a NURBS object from my sub-D object. Now the downside with the NURBS is now it kind of ceases to be editable in the same way that sub-D and mesh objects are. So you can select the faces, but if you move that around, it's going to kind of cause these continuity problems with the geometry. So if this is a NURBS object, you basically want to consider this done, you're done editing the object. Whereas if I did the same thing for the sub-D, it's going to smooth out and can maintain a smooth relationship. So that's kind of the major difference between some of these. And then the mesh is obviously like a faceted representation. So if I hit the tab button, so if you hit tab, you can also toggle display modes between sub-D, sub-D faceted mode and smooth mode. So when I hit tab, it said sub-D display changed from smooth to flat. So basically what that is now showing is it's now giving me the mesh representation of the sub-D object. Hit tab again, so that's a smooth object. So you can definitely smooth things out with sub-D geometry. But one thing that we're wanting to do and kind of create with the forms that we're working with is we want these to always be kind of maintain a relaxed minimal surface type of geometry. So for example, if we were just to work with sub-D, let me just take this and mirror it. And I'll show this really quickly, and let's join this. So I'm joining this mesh. And I'll just turn this into a sub-D object so we can view it. So if this is a sub-D object, by the way, if you want an entire edge loop for a surface on sub-D or meshes, you can double click the line that you clicked and you'll get the entire edge loop. But one thing that you'll see happening if you're just working with sub-D, you might get these kind of creases where this is not necessarily, it's not a crease, but it's not necessarily a continuous formal geometry. Now, it's not that this is a bad aesthetic or anything, but it is something to think about if you don't want that aesthetic and you want something to appear more like a minimal surface, then you have to use things like kangaroo and start to relax these types of mesh surfaces. So that is what we are going to do. So let me just go ahead and open Grasshopper. All right. So I have Grasshopper open now. So the first thing that I want to do is I want to set a mesh object. So I'm going to get my mesh. And I'm just going to set this mesh here. So I'm going to set one mesh. Apologies for the sirens. It's a New York life. Sirens constantly. Okay, so I have a mesh. You should have Weaverbird installed as part of the plugins package. If you don't, definitely install Weaverbird. But the first thing that we're going to do is we're going to subdivide this original mesh using Weaverbird. So when I use Weaverbird, I plug in a mesh, and I'm going to just turn this off for a second so we can better see it. Okay, so what this is doing is it's smoothing out, it's making a smooth representation. So it begins to, if I smooth this out by, if I get a slider 1.3, I want to go 1 to 3. And the reason I'm doing that is because Weaverbird takes levels from 1 to 3. First level is 1, 2, and 3 is going to be the most smooth. I preview this really quickly. So if I'm just looking at pure form of this, this does look like kind of like the sub-D object that we created, basing it off of a mesh. So it's not, though. What it is it's actually just subdividing it and smoothing out. It's using the Catmull-Clark algorithm to basically smooth the faces and turn this into a smooth representation by taking each face of the mesh and subdividing it down. So the more subdivision levels you give it, the more faces it's going to create and the smoother the representation of our meshes. It also gives us a couple options to fix the corners, smooth the corners. I think by default, it smooths them. You can also fix the edges. So if you wanted to smooth this, but keep the edges straight, you could also do that. I don't want to do that, so I'm going to keep them smooth for now. And for putting this into Kangaroo, I'm going to keep the subdivision for this around 2. You don't need to subdivide it a lot to get a nice relaxation from Kangaroo. So if this is the look you were going for, you could probably start and stop from using Weaverbird. But if you want to kind of take it further and relax it and actually give it some tensile force to approximate a minimal surface geometry, you will need to use Kangaroo for that. So Kangaroo, actually using Kangaroo 2, that's the old one. So Kangaroo, when we're using Kangaroo, you basically give it goals. So what goals are doing is it's trying to approximate, you're basically giving it forces, and it's trying to take each one of the goals and average them with a solver. So it's basically a type of physics simulation where it's running through the solver and trying to average the forces and kind of balance them to get a stable relationship at the end. So I'm probably explaining that horribly, but you'll see in a second what I mean by that. So I'm going to grab the solver here. Oops. Okay, sorry. So I'm going to grab the solver, and what the solver is asking for is it's asking for goal objects. It's asking for a reset. You can give it a threshold value. You can give it a tolerance, and then you can give it, you turn it on or off with a toggle. So I'm going to give it a toggle, turn it to false for now, but we'll turn it on when we want to run it. I'll get a button to reset the solver. Well, I'll just turn this toggle to true. So we need some goals to basically relax this mesh. So the first thing we're going to do is we're going to get edge lengths. So in the goals mesh here, I'm going to grab edge lengths. And from edge lengths, I'm going to plug my, just going to get a mesh here and plug my mesh into the edge lengths. So for length factor, if we want to make this as close to a minimal surface as possible, we want this number to be 0. So you can also, so 1, the max of 1 is going to be, it's going to try to maintain its current edge length. So basically this is a factor of the length. So I want this to get as close to 0 as it possibly can get. So I'm going to plug 0 into the length factor. So right now, if we just plug length factor into goal object and keep it true, well, we saw, you might have seen something happen. So if I turn this stuff off real quick, basically it's all shrinking to 0. So that's because this is the only force that we're giving it. It's the only goal. So it is achieving its goal and turning everything to a length of 0. So it's basically collapsed all of these points. The edges of the mesh are no longer edges, and it is kind of collapsed to its center point. So we need to give it something else. And that next thing that we're going to give it is called an anchor point. So the reason we want an anchor point is because we basically want to take the edges, the edges, basically the vertices along the naked boundary. And we want this to essentially be the points that anchor it. So we want to think of those as fixed points in space that cannot move. So those become fixed points. So to get those, we have to take from a mesh, we have to get its vertex, its naked vertices. So I'm going to get the naked vertices component. You could find that under the mesh and Kangaroo. And then I'm going to take the mesh object, I'm going to plug that into M here, and it'll give you the clothed index, like the clothed points. What clothed points are is the points in between, but I want the naked points. So these are basically all points along the edge of my mesh. So if I turn this off, I can see those become my anchor points. Okay, so I'm going to plug those into P, and the other options, you can give it a target. We don't need to do that. The strength is set to something extremely high, so it's going to basically kind of prioritize your anchor point over all the other goals. Like if you look at the strength of edge length, it's set to 1. We don't need to change those for this. So I'm going to get a merge component because best practice, like I don't want to shift click a bunch of things into my goal objects. The problem with doing that, like it's fine, it works if you do that. What I don't like about it is that you can't really tell where the inputs are coming from unless you hover over, and I don't know, it just makes it, if you're working with other people, it's just better to use merge component. So I always use the merge for goals. So I'll turn this off, turn this off. So, okay. We can see now that if I plug this again, we are actually relaxing this mesh. So this is cool. When I look at this solver here, my outputs are actually just lines. So with Kangaroo 2, the solver, it's basically just giving us lines and points. So we've put a mesh object in here. So there's one way that we can deal with this in the last step in this process. So we're almost done like relaxing the mesh. It's a pretty simple, straightforward process to do. The last thing that I want to do is show my mesh. So there's a component here under main that is a show component. And all you need to do is plug your mesh object into the geometry that you want to show. And I can make a little input here in my merge component and plug that into D1 of my input. And now my mesh object will be seen. So the last thing that I want to do is right now I'm getting the lines, I'm getting the vertices. I only want to isolate my mesh object. So I'm going to get a list item here. And I'm going to plug the O output. So this is O as a tree output into the list item. And I just need to flatten this. So flatten the list item. And I can take a mesh object. So that top item is always going to be the mesh with show plugged into the first vertice. So threshold and tolerance. So is asked in the Q&A what threshold and tolerance do. Tolerance is basically saying like if your points are a certain proximity to each other. So if I'm relaxing this mesh and this point gets very close to this point in my simulation, it will collapse those and converge them into one point. And the threshold is actually something we can utilize a little bit. What the threshold does, it'll kind of help us actually for what we're doing, because what it's saying is there's each iteration, after each point of iteration, when you're running this, like this is a very fast simulation. We don't see it doing a lot of iterations because it solves very quickly. But when you have a more heavy solver, which will it'll start to get heavier as we give it more geometry. Like it'll even get heavier if I up the subdivision of this. So you see how it got a little more bouncy there. So what it's doing is after each iteration, it calculates the displacement. So like how much wiggle room did it have between each one? So if you give it a threshold of, let's say 1 millimeter, they'll say, okay, if the points are within if they're moving only a millimeter, then in the simulation. So that's basically what that's doing for us. So I could get a panel and whoops, and say 0.0001, put that into threshold, and now it's going to take a little bit less time to calculate the simulation. Okay, so let me turn this stuff off. Take my preview here, drag it over. So yeah, we can always look at this way. Let's make it gray. It's a little easier to see that way. Okay, so yeah, that's our relaxed mesh. So we can just look quickly at what I was talking about a little earlier is, this aesthetic here. So if I wanted to take this mesh and set my mesh, right, that's going to probably greatly stretch out because it's trying to create this, make this as minimal as possible. So, we have a very large span. So at the shorter spans, it's tighter, and then at the longer span, it's going to be thinner. So I don't think that if we even tried to make this move with Kangaroo, I don't think that it's going to even accommodate that. It's going to continue making a span. But now that we've changed the span, this is, changed its crease a little bit. So it's always going to, basically what it's doing is it has our anchor points here, and it's always pulling our geometry tight from one to the next. So even though our geometry, we've kind of moved it off to the side, because it's always trying to relax this so that it's taut between one set of anchors to the next. It's always going to find the minimal span to do that. So that's why we call these things, partially why we call them minimal surfaces. I mean, with Kangaroo, they're not completely a minimal surface. It's more of a pseudo minimal surface because it's not like mathematically deriving and optimizing its minimization, but it's pretty close. So, for all intents and purposes, that's what we call them. Okay, so yeah, this is basically the process for using our Kangaroo mesh setup. So let me save this. I'm going to save this in the folder as the workshop working file. So I'll save this along. So if you ever get lost at any point, you can come to this and use it. So I'll save that. And let me just save this file so you can take a look at this. So we can look at these other examples too. Let me turn off the one we just made. So yeah, let's look at this example. So this is one, basically I just made this in the same way that we made the other meshes. If I set this here, this one probably takes a little longer to relax. It has many more faces. Okay. So yeah, I mean, it doesn't really matter what kind of mesh, like this is just a weird one that I made just by extruding faces and, subdividing things and deleting faces out where I wanted. But you can kind of see what it does when you relax it, with just something with protruding faces in the way that I've done it. So the Weaverbird had smoothed out the edge, and then we're just using that edge to act as an anchor point. So it's something you can play around with. Yeah, it takes a little longer to converge. So we can kind of keep this at something like 1 for this shape. It's a little faster. Okay, cool. So one thing that I want to show how to do, and I'll just use this as an example of how we can do this. But I'm going to take this and I'm going to copy everything down, and I'm just going to disable this first one. So this, I'll group it and just call this kangaroo mesh relaxation. So I want to kind of save us some real estate over here with this, and save this. And I'm going to turn this into a cluster, basically. So to do that, we need to basically set up all of our inputs and get the proper input that we want. So basically the inputs, if we kind of look at this, I don't want to include the subdivision. I basically just want to get our base mesh. So, you know, we don't have anything hiding in there that we don't want. So with a wire structure that represents structural load bearing. So yeah, you can get into, that's like much more advanced stuff and kind of teetering on structural engineering type of stuff. I think what like ways that you could do that is you could use the Karamba plugin. There's kind of other more advanced. It's like too much probably to get into like specifics of that for this. But you know, it is possible, and there are people that kind of do that kind of thing. So wrapping around the geometry. Yeah, I mean, there's different, it kind of just depends on what you mean. Like there's a lot of ways that you could wrap geometry, like there's shrink wrapping. You can definitely use Kangaroo for that. But for like structural analysis stuff, probably Karamba is a better plugin for that kind of thing. I think it's a pay for plugin, and I don't think it's free, or maybe there's a free version. I'm not 100% sure about that. So hops, I originally intended on going through hops, but the problem with hops that I've encountered, and I've been like trying to implement this even at my office and things like that, I find it just inconsistent. Like ideally it has better computation, but I have not really found that to be true. And I've also found that it has created some memory leaks on my computer and caused my computer to crash. Not my computer, but Rhino to crash. So I don't know. I understand that it's ideally more valuable to use than clusters, but I have not really seen that value. So if someone could show me that, actually, that would be great. But as of now, I don't know. I don't see much reason to do that beyond using clusters at this time, at least at the state of how hops currently is. But yeah, I mean, the ideal of hops is that you can parallel compute things. Okay, so for this, I'm going to make this a cluster and kind of use clusters for this. All right, so our other inputs here, we have button, we have threshold. I'm not going to mess with the tolerance. We have a Boolean toggle. So I'm going to get a Boolean. I'm going to get another Boolean and put this into our button here. And this is a number. So I'm going to get a number, plug in there. So reset. So the reason I'm doing it this way is because these are going to be what I'm going to name the inputs. So I'm just going to call that reset. I'm going to call this threshold, and I'm going to call this run simulation. Could call it on. And then for mesh, I'm just going to duplicate that so I always know I have a mesh coming out. And we could just keep that as a mesh object, or I could call it something like output mesh. And then for this, I can call this input mesh. Okay, so these are the things that we're going to use to create our cluster. So I want these things to be outside of the cluster. Oh, one more thing. Well, we can actually just leave this length factor to 0 because I'm never going to change that. If you want to give it the option to change it, you could give this a number and call this length factor. Just so it's exposed. So yeah, so basically when you're creating a cluster, you want everything that you're trying to cluster to exist outside of your cluster, and you want your inputs to be logical and coming in to basically these types of things. Otherwise, it's going to name it some default value that you might not want, or it's not going to name it anything. So it's important to kind of know what your inputs are and set your inputs. So basically what I can do is from output mesh to these inputs, I can just drag over, select all of these objects, and I'm going to middle mouse scroll wheel and turn this into a cluster object. So I'm going to press cluster here, and now I have turned this kangaroo definition into a cluster for us. Okay, so now this is a cluster. So a disadvantage of clustering in Kangaroo is sometimes you have to reset this more times, just the way that it computes. So it kind of comes to the computing question. The nice thing is it does save us some real estate. So in the example file in the folder that I shared, there's user objects here. So all of these user objects, make sure you install these. You can just drag them, like you can take them and drag them into, once you've downloaded them, you can drag them onto your canvas. And what they'll do is they'll show up here. So continuous formations. So they should show up here, and then there'll be the user objects. So we just made this cluster. You can rename clusters. You can hit the properties to clusters. You can call this something like mesh relax, and you can call the name that too. So right now it says cluster. I'm using sunglasses to label components. So now it's labeling it as mesh relaxation. You click into clusters. You can, if you need to edit anything, you can click in and do that. Another thing, so basically we can construct this entire workshop, like for the minimal surface part, just using these clusters. We can build this definition really quickly just with 6 of these components. I think that's not as fun since you're not actually learning how you do it. So we're going to actually go through the process of learning how we do this. So yeah, the mesh relax component, I've already kind of created this cluster and shared it in the cluster examples in the user objects. So under user tab, you go to continuous formations, you'll find this as the relax mesh. So I named it relax mesh. This one I called mesh relax, and not always, it doesn't really matter. You can call it whatever you want as long as it makes sense and, you can find it and use it. All right, so in here, in this file, I have a couple examples here. These are the minimal surface. So if you've seen my work, I think it's been linked to my Instagram. I'm doing this kind of stuff often, rendering it in Blender, but this is basically the process that I've developed and I use to kind of create these minimal surface types of geometry. So the essential logic of this is basically I'm creating a mesh network kind of similar to the meshes that we just modeled manually. But I like to do this stuff generatively. I don't like, sometimes I like to model things, but other times I just want Grasshopper to take that work for me and I can iterate through the options with sliders. So I set this up in Grasshopper to basically be a closed cell mesh network that I can then take another geometry. Let's say it's a sub D geometry or, you know, whatever. This is using basically a box as my base and I'm smoothing it into a spherical type of geometry. And then I'm trimming out the edges and then relaxing it in Kangaroo. So we'll go through the process of how we do this. So I'll turn this off. I'm going to go ahead and, so we have this up here. I'm just going to delete our inputs here. So we just have a mesh, we have number slider, we have these things. So I can group those, keep those together. So we're going to use this, but I'm going to move this off to the side so that we can, and I'll just group this so that we have it. The thing that I want to do is I first want to create our mesh network. So the way that we're going to do that is we're going to create a system for using a 3D Voronoi object or Voronoi 3D. So the first thing that I want to do for a Voronoi 3D is I want to create a base box. So I'm going to get a box. I'm going to get a domain box. So we get a domain box. It'll ask for values. So each value is expressed in terms of a domain. So I don't care if I wanted to start at 0 every time, I can just plug in sliders to this. So I'm just going to get sliders, let's say 40, and I'm going to copy this 3 times for my X, Y, and Z. So for purposes of starting this out, I can just maintain a box. We'll keep a cube of 40 meters by 40 meters by 40 meters. So that's going to be our box. I'm going to output a brep, so we know that this is a brep object. There's a couple of things I want to do. So in Grasshopper, under the Mesh tab, you can get a 3D Voronoi object, so Voronoi 3D. What Voronoi 3D is asking for, it's asking for points, and it's asking for an optional boundary object. So we need to create the points. We can do that with randomness. So I'm going to create, well, actually, I'm not going to do a random. What I'm going to do is I'm going to populate 3D. So there's different types of populate geometries. There's populate 2D, populate geometry, populate 3D. Because all I want to do is populate my boundary box. I want to fill this with random points. So it's going to ask for a region that's going to be my box. So I'm going to plug my box into R here. And now I have a bunch of points populating inside of this box. So you can change the number of points. That's the count. You can give it a seed value. That's going to be basically just changing how their points are randomly distributed. And it also gives you an option to give it pre-existing points. So I think before I populate this with this box, because I kind of want this box to be the maintenance box that we're using for the trimming of the Voronoi. So what I like to do is I like to give this a scale factor. So I'm going to get this box. I'm going to scale this, but I want it to scale by the centroid. So I'm going to get the volume of this. So I'm getting a volume component. I'm plugging my B rep into the volume here. And I'm plugging C into the scale. So by default, it scales by a factor of 0.5. I don't want it to be quite that low. So I want my factor to be something like 0.95. What that's going to do is it's going to, if I plug that now into my region to populate all these points that are kind of close to the edge, it's just going to pull those a little bit off of the edge because I don't necessarily want them. If I'm going to contain, you'll see in a minute kind of why I like to do that, because what will happen is if it's too close to the edge, it's going to create a cell that could be very small and hugging the edge of my boundary box. And I don't necessarily want that to be the case. So this is something I can kind of change the factor. It doesn't really matter. Another thing that I could do is maybe I could say, I actually want this to scale up, and that might be the boundary. So I could optionally say 1, 2, 1, 2.00 or something. 2 is definitely high. Scaling it by 1 is going to give you the original box. Scaling it a little higher, that gives us a little bit of wiggle room to where our box ends. I mean, if you have this, you probably don't need this scale, but sometimes it's nice to have it. So, okay, let me turn off some of this stuff so we just have our points. Before I plug this into the 3D Voronoi, I'm going to set a number for my populate. And that number is going to be, I'm just going to get a slider that says 25. I don't necessarily want this to be a lot of points right now. For the seed, what I like to do is I like to get a large number for the slider, maybe 500 goes, so I get a slider from 0 to 1,000. Sometimes I go higher than that, something like 5,000. So as I change the seed, you can see that it's just changing the distribution of the points within the region. So I've created this possibility to scale the box up. I've created this to scale it down to populate the points. So my points for the 3D Voronoi, I'm going to plug into here. And right now you can see that it's just contained around the edges of the points. What I want this to do is actually, I want to use this region here to scale up so that it'll get the Voronoi around each point, but then also use my base box as the boundary region. Okay, so this is what we have so far. Domain box, we're scaling it by a factor and we're populating 3D. Okay, so on to the next step. So basically to create the mesh network that I'm talking about, what we need to do is we need to scale our face geometry. So we want to scale each one of these B reps. So we have a closed B rep. We have 25 because that's how many points we have. So I'm going to get a B rep object here. So we know we're always working with that. And I'm going to get the volume of each one of these B reps. So you could scale it by our populate 3D points, but you can see that when I get the volume, that's actually giving me the centroid of our object. The points are not going to be the perfect centroid. So that's why I'm getting this volume component here. And I'm going to get another scale. So we scaled by volume before. We're going to do the same thing. So the centroid, that's going to be our scale, our center of scaling. And then I'm going to plug in this here to, I'm going to plug the B rep into our geometry. And I'm going to get a scale factor. By default, it's 0.5. So I'll just get 0.500 just to give us some leeway there. So yeah, I can change the slider and scale these down as I see fit. So now what we want to do is we've scaled this down. We want to now take the edges of our B rep here. So we want to take each edge of this, of our original one here, and we want to loft those. We want to scale the faces and edges, and then we want to loft it to this. So it'll kind of create this network type thing going on. So you'll see in a minute what we're doing there. Okay, so I have my scale geometry here. I'm going to get the deconstruct faces. Deconstruct B rep. So we want to deconstruct our B rep. If you struggle to find where that is, it's lives under the surface tab. So deconstructing the B rep, I'm going to plug that in. What that's going to do is it's going to give me the face of each B rep and all the edges, but I want to get these face objects, and I want to get the edges of the face objects. So I can get B rep edges here, and I want to get the naked edges of each one of these. So right now, the naked edges, if I hover over this, it's going to be in the form of lines. So I really want these naked edges to be joined into a single closed polygon, polyline. So what I'm going to do is I'm going to get a join component. So join curves here. So joining the curves, what I need to do now, and I'm going to do this same thing for the faces here. So I've joined the curves for this. I could just copy this little snippet because this is what I want to do the same thing for our scale curve here, or our scale geometry. It's out of the way. So we have our Voronoi B rep. Now we have this B rep here, and then we have this geometry that we're scaling. So we haven't scaled this yet. So we're kind of this way. We've scaled first, and then we've got our edges. We want to do the opposite here. So instead of volume, I can get the area of this join curve. So if I plug area into G here, I can use this as my centroid of my object. And then I can plug in, I can get a scale component and scale this by the centroid. I could just copy this slider here. So we have another slider, plug that into the factor, and then plug that into the geometry. Okay, so now this is a curve. And this is a curve coming out of here. So we have a curve and curve. If I turn off the rest of this, I have a bunch of curves that I'm now scaling this along the center of our original joined curve. So you can see that. So it's always scaling this geometry that way. And then it's always scaling our other geometry from the center of the B rep. So basically the thing that I want to do is I want to take this and I want to loft that to that. So I could quickly do that. So I can take this geometry and I can merge this. Merge it, the data tree should be matching. You should have 2, 2, and 2. So one of the plugin downloads was Chromodoris. The only reason that I'm using. Chromodoris does a lot of great things with voxelization and isosurfacing. The reason I'm using it for this is simply that it has a really great mesh loft component. It's very fast and it works well. So I can take the 2 points and I can loft the mesh. The other alternative, if I didn't loft the mesh like this, is I could loft these as using a regular Rhino loft and then turn it into a mesh. So if you didn't have Chromodoris, you should, I think, is part of the download files, you should have it, but you could just loft it and then turn it into a mesh. Like, that's another way to do it. It's just, this saves us a little bit of time by doing a mesh loft this way. So it just automatically gives us a loft. So if I turn the rest of this stuff off, I can get a preview just so we can look at this. Sometimes it gives us that strange look. But let's just look at this, what it's doing. So we can scale these faces. We can scale down our center points, right? So what's cool about this is that we can just kind of control the middle geometry. We control the face geometry. But one thing that you will see is we sometimes have faces that are extremely small. So we have a face like that. We don't necessarily want to deal with that. We might not even want to deal with ones that are this small. When we go down the pipeline and start relaxing this a little bit, you know, these things might cause us a few issues. Like, those faces, we might not want to be that small. So we can write a function actually, like before we loft this, to remove that. So I'm just going to take this off to the side. And we'll think about that in a second. So I have my scale curves here. And then I have my curves. It's really these curves that start to get small. That's what I want to cull. So I basically want to remove anything that is smaller than a certain value. So the way that we're going to do that is we're going to use the area component again. So if I just copy and paste this area component here, I want the area. So I have the area. I don't want the center point. What I want to do is I want to evaluate this area so I can get a component called smaller than. So smaller than lives under the math tab under operators. But what smaller than will do is it'll say, if a value is smaller than another value, it'll create just a pattern. It'll create a Boolean pattern telling us if it's true that it's smaller, false if it's not. So I'm going to plug the area into A, and into B, I'm going to get a number. So maybe I'll get a slider saying 2.000. This will give me a slider from 0 to 10 that I can play around with. So basically what the slider is, it's whatever units in your Rhino document. Since we're in meters, this is 2.1 meters right now. I'm going to say if the area is smaller than 2.1 meters, I'm going to just saying, is it true or is it false? Then I can get a dispatch component. So I want this dispatch here because we don't want to cull it, because we actually want both. We want to basically separate whether it's smaller or not. So I'm going to plug my curve into L of dispatch, and dispatch you can find under the tree tab under list. And I'm going to plug in the less than component into my dispatch here. And it should give you a list of the ones that are smaller in the top. So if I get a curve, these are going to be my smaller curves. So now we've isolated that. We know that that's that curve there. Sorry, let me turn this off. Okay, so we can see that we actually have quite a few curves that are smaller than the ones we want. So we basically want to take these and we don't want to loft those to these curves. So I'm going to move this here, this other curve. This is the one that we want to, these are the ones that we actually want to loft. These are the ones we don't want to loft. So what we have to do is we have to take the ones that we don't want to loft and we have to turn those just into a straight mesh. So the way that I could do that is I can use a pufferfish component called mesh to polyline to mesh. So, and we've got the author of pufferfish here, which is a privilege. So if there's any pufferfish related questions, the man himself is here. So polyline to mesh. We're going to plug that in. I'm going to turn that into a mesh. So then now what I want to do with these curves, I also need to isolate. So I'm going to copy this dispatch and I need to isolate the curves here that I don't want to connect and loft to these curves. So we actually, because we're culling this set of curves, I don't need them at all. I can get a curve component and just use this one. And I have this merge, right? I've created this merge component here. So now all I need to do is I need to merge this component to that and this to that. Our data should be the same. And this is giving us an error probably because we don't, let's see. Yes, it's giving us an error because we have zero length tree. So what I need to do is get a component called clean tree. And clean tree is going to clean the tree. So if I have empty branches, so clean tree is going to be found under the tree tab here. So whenever you want to see a component, by the way, let me just save this. If you want to see a component, you just hit Control and Alt and left click a component and it will show you where that component lives in the tab at the top. So that's just a helpful feature if you're unsure about where something exists, or if you're doing a tutorial like this and you can quickly show people. So, okay, we want the clean tree and we want to remove empty branches. So I could just right click the E here and invert this. So if I right click and invert, it's going to set, by default, it's to false. If I invert it, it's set to true now. Now I can plug that into my mesh loft. And that's great because now what we have is we have this mesh network that's no longer including our really small faces here. So we're never getting a situation where we have these tiny faces lofting to another tiny face. And what's cool about it, like if I say, okay, that's too small, I can tune this to increase the size. So we can kind of really adjust the threshold of what's getting lofted to what. So now you can see, okay, all of these are not within our threshold dimension. And you know, we can forget about them. So yeah, this is very tunable. And you can see kind of, if we take it down to 0, now we're going to get those really small segments back. So question, okay, you got the, we'll let Mike answer that one. Okay, so the last thing we need to do for this network process is we need to take our mesh and we need to merge these and then join these things together. So I'm going to get a merge component. I'm going to merge my mesh loft to my polyline to mesh. Okay, so now these are merged in the same list, and I can flatten the input or I can just flatten the output. It doesn't really matter. So I'm just going to right click this R output and I'm pressing flatten to flatten it. And then what I want to do is I want to get a mesh join component. So got mesh join here. I'm going to plug that into join. So let me turn this stuff off just so we can see the mesh. Okay, so now we have a joined mesh. So we're not quite here at the end of the road yet. What we need to do is weld our mesh. So I'm going to get a component called weld. So that lives in the mesh tab here. So one thing, when I look at this welded mesh, so I have everything else turned off. One thing that's nice about using Rhino 7 is that it tells you when it kind of gives you a display for when certain things are not completely joined. So this kind of thing, when we're like using certain computational tools in Grasshopper, it's kind of a problem if your meshes aren't completely welded. So for some reason, I don't know why, the base weld command, like it works pretty well, but for certain things, it doesn't always weld everything. And that's kind of always been frustrated. No matter if I change the tolerance, it doesn't really do much to like in these kinds of situations. So this is a plugin. This is another plugin on the list of plugins. Weld vertices. So mesh weld vertices. This is from the mesh edit plugin. I think it's a super old plugin and probably hasn't been updated in a long time, but it probably is like the most reliable welding, like vertex welding tool. So I use this all the time in my workflow. So like sometimes what I'll do is I'll weld it first this way. And then for good measure, I will put it into this welding tool. So 0.01 doesn't work in this case as a tolerance. I'm going to take the tolerance to 0.0. Whoops. I'm going to get a panel and put this at 0.001.
Yeah.
Hey, what's up?
It's going to mention that if you want also the rebuild Pufferfish rebuild mesh has welding, because
oh right,
this one like fails sometimes in new Rhino.
Oh right.
If you want to use it, me and David Stoshik like rewrote it together. It's a lot faster too. Like you don't have
Cool.
that many vertices, but just letting you know, it's there if you want.
That's your rebuild.
Yeah, and the rebuild mesh. It's the like the last input, the W input. It's
Right.
also a number. Yeah.
All right, cool. All right, let's try it.
Yeah, you can use either one, but usually we were just finding that the other one was failing in a lot of situations we needed. So yeah.
Interesting. This one, right?
Yeah, in Rhino 7, it was like messing up. And as you said, it hasn't been updated in like forever.
Yeah, exactly. So basically all you do here is give it a,
Yeah, you can just plug it in that W1 there.
look at that. Beautiful. And it's not recreating any faces, it's just welding it, right?
Yeah, and you could turn I, because I is combining identical. It's,
right.
It's faster than welding, so like you can get rid of a lot of stuff with that, and then like catch threats of it with the welding.
Amazing. Okay, everyone.
But yeah, there you go.
Cool.
Anyway, just letting you know.
Yeah. No, I mean that's great.
In there.
Great.
Yeah.
Yeah, I mean, I remember like for certain things, like the meshes fail, and this is a great component because you can plug it in and I guess that it is probably the welding, right? That's what the problem is. Okay. No, I haven't, you're right. I haven't encountered that. For this part of it, I never had the failure, but down the pipe, I remember this was a helpful part of it. All right, cool. So we're not going to do this anymore. We're going new school. We're using Pufferfish, rebuild mesh. And I'm going to, just like what Mike was saying, turn this identical combine to true. So I right click that, inverted it to true, and then I'm giving it a tolerance of 0.001. So within a millimeter tolerance, if the points are within a millimeter, it will, in my file, it will weld them. So this seems to be working very well and very fast. So awesome. And then there is one last step, because I don't know, let me try to bake this real quick and see if there's some problems, because what happens, oh yeah, so look at this. I have back faces turned on, by the way, in my display. I think when you're doing computational design, like, it's pretty important in most situations to understand your normals and understand like which way direction surfaces and meshes are facing. So I always have color back faces turned on. I set it to orange because orange is not a color that I usually use for layers or anything like that. So as you can see, this mesh is, its normals are all screwed up. So this is going one way, that's going another way. So I want to take that and I want to unify the normals. Oh, look, you can do that here. Look at Pufferfish over here. Let's see this. All right, awesome. So all the normals are facing out, but that doesn't really matter. What matters the most is that they are consistent, because we can always flip it. So that's awesome.
There's flip there too if you want.
Yeah.
The F input there.
That's cool. Yeah, I don't know if I care actually.
Doesn't usually matter for this stuff.
Yeah, I don't care. Yeah, I don't think I care which direction it is. I just care that it's consistent. But yeah, that's super useful in other situations. You might care, like, right, you might need it to be consistent to one direction. For this, it's kind of like a network that's all over the place. So I don't think it matters. If it matters, we'll figure it out while we're working through this. So that's awesome. Okay. So this Pufferfish component is now a one-stop shop for all these kind of mesh welding and flipping. So that's great. I'm just going to use this from now on. Cool. And now we can output a mesh. So we have a mesh network. This is what we're going to use as our basis for basically the whole network. So yeah, what we've just done is this. We can change, the value of culling the faces. We can change our face scaling parameter. You can make that high, you can make it low. You can change the scaling parameter of the center. If you make it too low, things start to disappear. You probably don't want it to go like extremely low for that one. But yeah, so we can start, really doing some interesting things with this. So I'll just blow this up so you can see it. And I'll save this file so it's there. So to show the full name of the components above the components, I'm actually using sunglasses. I don't think it comes with Rhino set. Now I don't remember. I think you download it. You have to download it from the package manager, I think. Is that correct, Mike? Do you know?
I haven't used sunglasses.
Yeah. I think what I did is
Might be on Food for Rhino.
yeah, it might be on Food for Rhino. I don't see it here. Sunglasses. Okay, I think it was something you install. Maybe it's not showing up because I have it installed. So I think through the package manager, you can search for sunglasses. And then when you have that, it's under the display and it shows sunglasses, and you can basically just toggle things on that you want. So that's how I have that. Yeah, bifocals is another one. I used to use bifocals. I don't know why. I just liked sunglasses because it was.
Sunglasses is actually better because bifocals is all bifocals is doing is making like a invisible group and then like
Yeah.
naming that group, and it's really annoying to get rid of. But this one is from Danny, I think, and it's a display thing. It's not like a trick with like a group.
Right.
So
That's a
it's
good
better,
point.
yeah.
Yeah, that's probably why I was using this. It just seemed better when I was using it. So uh, that's probably why. All right, I think we can take a little break. It's been an hour and a half. I'm gonna take how to make the shape more smooth. Um, if you what do you mean by
next? I think it's just
yeah,
probably talk about what you're gonna get to next.
yeah, it's gonna get extremely smooth very soon. So be patient. We will get there. All right. How about we take about 5 to 10 minutes and we'll come back to the next section. So the next
Yeah,
section.
let's just
So
do like 10 minutes. I think it's fine.
yeah, 10 minutes. Sounds good. I'll leave this open just so in case people want to see. Catch up to that. I've saved it. So you can also, if you need to catch up, you can open up the file. All right, cool. So I'll start back here at 12:40. Okay, I'm back. So how's everyone doing? Good. Just as a reminder, I'm saving these files. So this is workshop working definition. So I'm saving that here. The example file. Actually, I'm gonna save this as, so I know I've saved the example file. Sorry, I did not do this earlier, but I'm just going to also save this as the working file. So realize I don't necessarily want to write over the example file with everything new. So cool. Resave this as the working file. Okay, so the next part of this workshop, this is kind of getting into, we've kind of done the easy part. We're getting into slightly more advanced topics. So basically, the things that I want to do is we're going to trim the mesh. So we're not actually going to trim anything. We're going to basically take an input shape and then remove faces of the mesh from that. Then we're going to do some steps to clean up the mesh, remove things like non-manifold vertices, and I'll explain what that means. And then we will be smoothing the edges from the trimming object because it will not look good for the next, I don't know, 30 minutes to an hour. It'll be pretty jagged, but then we'll work on methods to kind of make this thing smooth, and then we'll kind of set this up in Kangaroo. So yeah, I think we'll get to some interesting kind of smoothing. So the next step is what I call a trimming process. So I don't actually, you can trim the meshes this way. You can use like mesh trim, things like that in Grasshopper. The reason that I developed the method that we're about to go over, though, is because my problem with just plain trimming was twofold. One issue is that with trimming, you get a lot, if you trim a mesh, you get a lot of like extra jagged faces that come into the mesh. And that's not something that I necessarily, it makes it a little hard to work with when you're putting it into Kangaroo and smoothing it out. So you can end up with kind of lumps in your surfaces, and this is continuous formation, so we want this to be continuous. Another issue is that you could get good results. You can refine it, so you can use there's some Pufferfish tools for rebuilding the meshes, for refining the meshes. Then you can use things like quad remesh. Those are actually great and they work pretty well, but my biggest problem with those, at least for if I want to rapidly see results, is it's pretty slow. So you change one thing, you have to wait how many seconds it takes to calculate. Sometimes it's 10 to 12 seconds. It could be 20 seconds, depending on your geometry. And every time I want to change a slider and I'm waiting 20 seconds, for me, it can be slow. It's a good process if you need something super refined, but if you're just trying to quickly iterate and look at things, then this method I think is a great method to use. So that's what we are going to do. So the first thing we're going to do here is we're going to take this mesh and trim it by basically our input box. So I'm going to take this B-rep here. So I'm going back to the very beginning of our definition, getting a B-rep. I'm going to take this boundary B-rep over here. I'm going to drag this thing all the way over here. So we want this thing at the end where our output mesh is. So another point that I just want to make real quick is, so we just set up this whole thing to basically do our 3D Voronoi mesh network. In the user objects, if you want to get here with just a user object, you can also do that with the user objects that I shared. So that is going to be this Voronoi mesh network. So everything that we've done here, so let me just group that. It's the Voronoi mesh network. Everything we've done here is also in a user object. So you can put your input geometry, which is our base mesh, and then you can input these other values in. So Juan, just to kind of field your question a little bit, it's hard to say like practical application. It probably could be a lot of things, and then you can get kind of philosophical. Like, so without kind of answering prolonged thing, I mean, a lot of it, maybe practical is not necessarily the word that I would use to describe it, but like you can think of it as kind of artistic. Also, you know, if you are thinking of pragmatic reasons for using these types of structures, I mean, one thing could just be like minimizing span. If you're using kind of minimal surface type of geometry, you know, I think there's a lot of things we could get into the weeds on. I don't know if we have all day to just talk about the use cases.
Yeah, I think
these types of
it
things.
can be anything. I mean, it can really be
Yeah.
anything that you think of. Structural, 3D
Exactly.
printing. Also, this isn't an architecture webinar, so. But yeah, it could be anything. Yes.
Exactly.
Just use your imagination and, you know, use the tools to twist them to do what you want them to do.
Definitely. Yeah, I mean, just being creative about it too. So yeah, thanks, Mike. Okay, so what I want to do is I've dragged this VREP over here, and I want to turn this into a mesh box. Since we're dealing with meshes, we want to also be working with meshes. So the mesh box by default is going to set a mesh over here. I want this mesh to be actually my VREP. So B goes into B. Right now, this box has like a ton of faces. I'm just going to bring that down and set my faces to 1. I'm just going to plug in a face count of 1 to the X, the Y, and the Z. So then the next thing I'm going to do is I'm going to turn this into a sub D from mesh. So the sub D stuff you can find under surface, sub D. So sub D from mesh. I don't need to mess with any of the defaults. I'm just going to plug in my control mesh. And if I turn this stuff off and I look at this, so the only reason I'm doing this is because it gives me a nice spherical type of surface. So it's not a perfect sphere. It's a sub D object. It's kind of interpolating a sphere type thing from a box. You could also just plug in you could do some math and like find a sphere that fits within the boundary region. This is just an easier way to, I don't care if it's a perfect sphere right now. I just want it something smooth to trim my mesh with. So I'm using the base box and kind of creating this sub D sphere type of thing. And now, so the only reason I've used this sub D is so I can turn it back into a mesh. So mesh from sub D. And I'm going to plug my sub D into here. And then you can, let me just turn this off so we can see what we're looking at. Okay, so this is the sub D object. And then our mesh is just creating a faceted mesh from that. I'm going to set this to a value of something like 5, just so it's, you know, smoother. It doesn't have to be that smooth, but it really doesn't matter. So I'm going to use this as my basis for, basically, it's going to be the only thing here, the real thing that matters I'm just going to use the regular weld. I think it will work on this. Yeah, so I'm going to weld it using the regular weld component. And then I'm going to get a mesh object. The thing that matters for this workflow is that this has to be a closed mesh. So that's like, we haven't done any other things like mathematical operations or anything like that, where we're moving it from an open mesh or like trying to solve that. So just to make things simple, everything that we're dealing, any kind of trim shape, and later on in the workshop, we'll show how you can input custom trim shapes. But any trim shape that we use, it just has to be a closed object. So since we're starting with a box, that's automatically closed. So this stuff is basically creating our trim shape. And now we want to essentially trim this mesh. So we're not actually trimming it. What I'm doing is I'm going to subdivide this into faces, or subdivide the faces a little more. And I'm going to use Weaverbird for this. So I'm going to go to Weaverbird. And before we were using Weaverbird, we were using the Catmull-Clark subdivision. What I really want is I want to use Weaverbird's constant split quads. So I'm always going to split this into quadrilateral faces, which is helpful for us because way down the road when we're kind of finishing up this workshop, we're going to be putting this into pufferfish, and quads are super helpful for that. So we're going to turn this into quads. The nice thing about this is, so right now it is smoothing the edges, but what I want this to do is I want to have the 0 as the value because I want it to be fixed. I'm just going to get a panel and plug that into 0. The default subdivision is 1. So basically what we've done is we haven't smoothed the shape or like changed the shape at all. It's just subdividing our faces. So it's basically the equivalent of when we ran the subdivision command in Rhino earlier, and it just split the faces of our mesh. This component with that turned to 0 is doing the exact same thing. So it's Weaverbird. So these subdivisions are 1, 2, 3. Don't know why they did it that way, but they did. And yeah, we'll keep this I'll just keep this at 1. I don't think we really need to go more refined than that for this. So, okay, that's going to be the mesh that we're going to now use to basically, we're going to see which points of the faces of this mesh are inside of this mesh. So our closed mesh that we're trying to quote trim unquote with. So I've done the quad. So the next thing that I need to do is I need to get the face normals. And I don't care about the normals, actually. What the normals component, it's called face normals, but it gives me the centroid of all my faces. So that's what I really want. And it'll give that in the order of the mesh faces. So I'm going to get a mesh inclusion component, which is under the mesh tab. So you're basically just seeing, is a point inside of a closed mesh. So the mesh for inclusion, only closed meshes are considered. So I'm going to plug in my closed mesh. I'm going to plug in center points. Those are my points. Whoops. Don't want to do that. Center points are points. And then strict. I don't think we care. It doesn't matter if it's strict or not. Maybe for some situations you care, but for this, we do not care. So great. Our center points are in there. And what this does, it just gives us a list of Boolean values. It's true if it's inside, it's false if it's outside. So what we can now do is we can cull faces. So this is a component that also lives under mesh utility. So it's cull faces, And what we're going to do is we're going to give it mesh face for culling, which is our mesh. And then we're giving it a pattern. So I think what this is going to do is actually give us the opposite relationship if I plug in this pattern here. Yeah. So if I turn everything off, turn all this stuff off. So by default, it's actually culling things that are outside of our trim shape. So we want the opposite of this. So I'm going to get a not gate. So it's gate not. And what this does is it's going to take all of these Booleans and it's just going to turn them into the opposite. So everything that was false is now true and everything that was true is now false. And I'm going to plug that into my pattern. Okay, so then this is what this gets us. In my preview from over here, I am now going to drag us along and preview. So that was our network. Now I'm going to preview our new shape. So we have this spherical shape with these funky jagged edges because all it's doing is culling the faces from outside of our shape and leaving us with the faces that are inside of this shape. So yeah, that's what this gives us. So we're not quite there yet where we're ready to smooth it. The next process of this is we need to kind of clean this mesh up a little bit. If I hover over here, wow, this actually gives us one mesh. That's amazing. Let me play with these parameters a little bit so that we can have something that gives us something we kind of want this to be screwed up a little bit in the first place so that we can visualize what we're trying to do next. Okay, do we have any floaters? So a lot of times what will happen is you'll have some faces that float out of here. Change the seed. Okay, let's see what this is doing. Wow, still one piece. Okay, it's fine. Sometimes when we're doing this, a face sticks out and we don't want a face to stick out. So just imagine that that might happen. So what we're gonna do is we are going to disjoint our, oh, that's why. I didn't disjoint it. So of course it's one mesh, it's all joined. But this is still one mesh because we don't have any faces sticking out. But sometimes when you disjoint the mesh, so okay, I'm getting the disjoint mesh command. So what that's going to do is sometimes you have a little face that's floating out here when you're working in this process. I, for the life of me, can't seem to trigger it right now, but when I do this, it's like almost every time there's a face tripping up. So of course, for the workshop, it's not repeating that for me. But that doesn't change the fact that we need to sort this and make sure that that isn't going to happen. So I'm going to get the area of our mesh. So this is going to have a basically what we want to do is we want to sort it by its area. So after we've disjointed the mesh, which can be found under util under mesh tab, we want to sort by sort list by the mesh area. So K is going to be the value that we're sorting by. Our mesh is going to be the A value that we sort. And we always want the larger one because what happens if there's a face floating off in space somewhere? We just don't want that face to be floating off. So the important thing here is I have my list item. I always want my list item to be the last item in the list. One thing I can do is I can come up here and I can press this to get -1, or I can just get a panel and say -1. So I'm going to plug that into my item, make sure that's always -1. And what -1 is, as long as you have wrap turned on, the list wrap, -1 is going to be the last item in your list every time, because your items, they start with 0. If you go to item index 1, it's going to be the second item, but item -1 goes backwards from 0. So that always gives you the last object. So this is a way to just always guarantee that we are working with the largest surface, which is probably going to be whatever our big mesh is. Okay, so that's our first set of cleanup that we need to do. In this case, it doesn't seem like that's a problem. The next thing that we need to make sure about, which it's hard to tell just by looking at this right now, but the thing that you want to make sure is that you don't have any non-manifold vertices on your mesh. Just look at this real quick. So yeah, it's hard sometimes just navigating, wheeling around to see if you have any non-manifold vertices. But basically we want to set up a tool that gets rid of what a non-manifold vertice is. I can't really see one here, but just to explain that really quickly, okay, on Zoom so I can annotate real quick. Okay, so a non-manifold vertice, let's say this is a mesh face here, and I have another mesh face over here. A mesh face is manifold if it shares a common edge and a common face. So this is manifold. It's non-manifold if I have this as a mesh face and then I have another mesh face here, and they do not share a common edge and they do not share a common face. So if it's just a vertex here where they're touching, that's going to cause problems when you're smoothing the mesh. So let's say like this mesh has faces sticking out like this. Like this is an okay mesh if it was like that. If this was like this, right, and it did this, like this one's okay. But if they're joined at the corner like this and they don't have any common edge, well, that causes a lot of problems, especially when you are smoothing your geometry. So one thing that we want to make sure is that if this situation happens, we want to go ahead and cull this and cull that. So basically, you know, we're left with a mesh that, let's say that's like this. It's never going to be like that, but so now this mesh is there, and then we're basically removing these two faces so that this mesh and this mesh kind of are separated. So that's what we're trying to do here. Okay, so to do that, I'm going to use Weaverbird. I'm going to get the naked edges of the mesh. I guess you can also use the native Rhino. I'm going to use Weaverbird. Just think it's reliable. Okay. I'm using Weaverbird. I'm extracting the naked edges here. And what I'm going to do here is I'm going to explode this curve because I want these vertices. So this is really why I'm getting the naked edges. I want the vertices of like the polyline because that's going to be important for, you know, how I'm going to extract. Because what we're also going to do is we're going to be using Kangaroo's naked vertices as well, because we want those indices and the vertices. So I want this, and I also want this. So I'm going to get Kangaroo's naked vertices of these edge, because I'm going to want to compare what we're about to do to the indice here and to the points. Get a point object, get the integer object. So I'm just going to go ahead and turn that off and leave it. And then we're about to operate on this. So first thing we want to do is a lot of these are closed edges. So I want to cull my duplicate points so that there's no duplicates here. I can set this to something like 0.01. And instead of averaging, I want to leave one. So if you're in the cull duplicates component, you can right click this and you can select leave one. So I'm going to leave one. And then what we're going to do is I'm going to duplicate this component again. And we're going to plug this point that we've just done into this point here. So I'm going to leave the tolerance at 0.01, also leave one. But the difference being is this point component, I want to compare all of the points from all of the curves, and I'm going to flatten this. So what that's going to do is if we have a non-manifold vertice, it's going to cull it. So if there's one of these kind of edge, just imagine that's attached to that. This is going to take care of that for us. So I'm going to now take this list and cull index. We're doing a string of culling here. And then I'm going to use the indice of our cull duplicates here. I'm going to flatten this list in my cull index here. So these points are going to go into here, and I'm going to cull the indice from this here. I'm going to turn that stuff off. So this gives us a culling list. And now what we're going to do is we're going to compare this list of culled indices to these. So just expand this a little bit. So what we're going to do is I'm going to get the pull point component. So I'm using pull point here. And what pull point is going to do is it's going to find the distance between this point, these points that are the naked points of our mesh, to these points. And the reason that we want to do that is because we're actually going to be culling the faces based on our vertices. So it's like kind of hard to explain in real time, but like the reason we're doing it this way is just basically the way the face order and how that relates to the point indices. Like we want to just have those always match each other. So that's why we're doing it in this kind of seems like a convoluted way, but it makes sense when it all comes together. So this is going to the naked vertices, since this is just the naked points is just a list of points. We're going to use that as our point for pulls. The ones that we've culled, the list that we've culled. So we actually don't have any. If there's no output here, it's because there are no non-manifold vertices. Let me see if I can try to create a situation where there will be. No. Aha. Here we go. Yes, let me pan around here. Here we go. Here's our infamous non-manifold vertice. So I'd already drawn this. So you know how I drew that sketch, but we can see in the model, like this is practically what it looks like. And that is, this is connecting to here. It's not connecting an edge. So right now we're trying to basically remove these faces and this face based on its non-manifold nature here. So yeah, this is a super important step because the problem with this is when you join it and you try to smooth it. So like, let's say I wanted to use Weaverbird to smooth this, or if I wanted to put it in Kangaroo and smooth my mesh, this is going to be really strange and it's going to create these pinch point conditions. We don't want those pinch point conditions. That's just going to make ugly geometry and it's not 3D printable. It's not really workable. So that's what we're getting rid of. So now we are taking our points here. We've identified the non-manifold points, which are here. Oh, this is why it looks weird. We don't actually need to do that. Okay, so that's our non-manifold point. We're getting rid of that. So the distance, what we can do is we can say, we can use our smaller than component again, and we could plug the distance into A, and then we can plug, we don't want it to be smaller than 0. We'll give it like a tolerance value. I'll use a value of 0.01 since that's the tolerance we're using. So about 10 millimeters here. And what I want to do is I want to cull our indices actually. So the points, like we've done the point operation. So now my index list, I want to cull pattern. So we're going to get a cull pattern and we're going to use the less than as our pattern, as our culling pattern. And I'm going to pull these integer naked indices from our naked vertices component here. And I'm going to cull those and plug that into the list of L here. And I'll grab another integer and plug that out here. So some of this stuff I can just go ahead and turn off. Okay, we don't really need to see that anymore. Okay. So we've done the work. We've got our integer, so we know which index in our naked vertices here. We know that's the index, that's a non-manifold vertice. So I'm going to get a mesh component just so we can work above this over here. So I'm going to take my original mesh. Let's drag this guy over. Okay, so this is our original mesh. So what we want to do is we want to deconstruct this mesh, and we're basically going to reconstruct it from kind of taking our cold indice here. Okay, so deconstruct mesh. Sometimes when you have a lot of plugins, it makes a mess when you're searching for things, but that's okay. Okay, so I'm going to get the deconstruct mesh component. That's found under the mesh tab under analysis. That's going to give us vertices of the mesh, faces of the mesh, even colors. If your mesh has colors, we do not. So this is just a useful way. So we're just going to look at the vertices. We're going to look at all of the vertices of our mesh. And we're going to get a list length of our vertices. So I'm going to grab my list length here, get the vertices list length. So 1940. If you hover over here, it tells you 1940. So that is correct. And I'm going to duplicate. So basically what I'm doing is I'm creating a list of values. So I wanted to create a list equal to the number of vertices because I'm trying to match the indices of this to basically cull the vertices out of my mesh. So I want to basically take a false, I want to take the value of false, and I want to create a list of 1940 equal to the number of vertices that are false. So I'm going to duplicate data. So the data that I'm duplicating, duplicate data can be found under the data tree tab, duplicate data under sequence. And I'm just going to duplicate false by the number of values is the number of vertices in my list. So now I have a list of 1940 falses here. And if this integer is 1587, I want to replace at 1587. That's the index of a naked point, then the total list of vertices, because that's the nice thing about using Kangaroo's naked vertices component is it gives you the exact indice. So I'm going to replace, I'm going to get a replace items component found under list, under your data tree tab. So I have this list of false values. That's going to be my list in which I want to modify. I want to replace an item. So the item I want to replace is a list of false values. I need true. So I'm going to get a value of true and put that into my item to replace with. So right now, nothing is being replaced because I don't have an indice. So the indice is actually going to be this one here. So I'm going to plug that here. So now the value at index 1587 will be a true value. I mean, we can't see it by hovering over, but you know that that's the case because we plugged in our index here. Okay. So we want to cull vertices of our mesh. So I'm going to get a cull vertice that's here. So we've already, that's similar to what we did with cull faces, but now we're culling the vertices. So what'll happen is if we cull a vertex here, it will cull also, it'll basically remove the face or turn, yeah, I think it'll remove that. So what we need to do is we have cull vertice. The mesh that we want to operate on is our mesh. So I can just plug in the original mesh here. The culling pattern. So it's asking for a pattern. That's why you can't just plug in an index to cull the mesh with. We're going to use this pattern that we just created. That's why we created this pattern in the first place. That's going to be our pattern. So as you can see, it's now created this, it's removed this, and now it's created a triangle face here because it's removed that index. And that is no longer a non-manifold vertice for us. So I just turn off this stuff, right? So now we can see our new mesh, our formerly non-manifold vertex is now been culled away. So one last thing that we need to do. So this is basically the step. Remember, I was like playing around with this to find one that was a non-manifold vertice. So what will happen then is if we did this process without one, this might actually like cause some issues. Like this component, I think, will turn red. So I think if we just plugged in false, 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 false to here. Oh, I guess it is working. There's one of these components, maybe it's just the replace items doesn't work. So we can just set up a little test real quick. So I'm going to get the list length here. So this is just kind of like a last quality of life type assurance thing. So we're making sure as we play with the parameters, nothing screws up. The list length of this is 1. I'm going to get 0 because I'm going to compare this with an equals component. So equals, same kind of thing that we're doing with smaller than. It's an operator under math. But if this list length equals 0, I want to basically filter the stream of information. So I'm going to grab a stream filter. This is a great component for doing kind of Boolean checks. So if it's false and I plug it in here, it's actually 0. So it's a value of 0. So since this is false, we can feed in our cull vertices here into the 0. And now that's going to be the output of here. If that is true, what we can do is actually use our original mesh. So if I just get a relay for this, I'll double click that, and in Rhino 7 you get what's called a relay. The original mesh can just come through, and we don't actually need to go through this step at all if there are no non-manifold vertices. So I could just do another relay so this is a little more clear. Okay, so that's our original mesh, and if this is equal to 0, this won't actually do anything, and then our output here will just be the original mesh that we're working with. Let's see if I can trigger that again. So I think I did this to 30 or 20. Nope, that was non-manifold. Now I'm gonna have the opposite problem. I'm not gonna be able to find it where none of it's non-manifold. Okay, here we go. So cool. What we just did is, right, so this creates problems. I guess it works now. I think when I originally created this script that there was a problem with this, that it didn't actually work. So maybe there's been some fixes. I don't know. Either way, this check will work. So if there's, we don't have any non-manifold edges, then that's fine. And then our mesh will go through. It'll say it's okay. It'll give us our original. If we do have a non-manifold vertice, then it will process it and then test us through. Three-sided mesh is okay to work with, yes. If you mean three-sided, like a triangle face versus a quadrilateral face, yes, it doesn't matter so much. I mean, I think we're going to try to keep it to quads as much as we possibly can, just because quads, you can. It's just better for using things like Pufferfish. But yeah, if it is triangular, then it's fine. It's workable. Okay, so we've cleaned our mesh. So we filtered it, we've trimmed it, and now we have cleaned it. Let me go back maybe to 25. Because I like to brute force kill my vertices. Okay, cool. So the next step, we want to work with a smooth mesh. So we've taken, now we have all these jagged edges. What we want to do is we want to figure out a way to make those edges, instead of being jagged, we want them to be smooth, like the examples we have here. All right, so we have our jagged mesh. So we've done our cleanup. So I can go ahead and take all of this stuff. I can group that. So in our steps so far, the things, if I go off to my user tab, the things that we have user objects for, we have our Voronoi mesh network that's there. this is our mesh rough trimming. So that's all of this stuff is that. This is a mesh rough trim. So this is all going to be this user object that I shared. And then this stuff is our cleanup mesh. So that's going to be our cull non-manifold verts, which allows us to clean the mesh up. And all of these are important for this workflow. Okay. So we've done that. The next step, we're going to smooth out our mesh. And that's this guy here. And one thing that we need is, so right now we've created our trim shape here. That's our trimming mesh. So I'm going to go ahead and just turn this into a green color. Whoops. This is going to be our trim mesh. And let me go ahead and save this file so anyone can catch up and find us. Okay, so our trim mesh. I'm going to take this. I'm going to just copy it and plug this in here so I can drag this thing all the way over. So this is from our trim shape over here. And so far we're creating this nice long string of definition. And I'm going to just bring this over here because I want this. I'm going to use this at some point in the process of smoothing the edges of this mesh. The part of the process that I'm going to do that for, or like what we need that mesh for, is if I turn this on real quick. So you can see everything is pretty jagged right now. So we're going to smooth the edges of our mesh. But what I want to do is I actually want to take the vertices of that, like after we've smoothed them out, and I want to pull them to the original mesh so that it kind of creates a nice clean, it's a nice clean geometry that's conforming to our original shape. So what's nice about doing it that way, and what I like about it, is that it, instead of trimming the mesh and getting kind of jagged geometry that we might not want, or like having to post-process it and kind of go through these like other types of processing, is it makes this kind of quick, and it also like will help us conform it to our original mesh. So it's kind of a way of like bypassing the trimming process. So you'll see in a minute what this is going to do and help us with. So I'll just go ahead and turn this off. So the first thing we want to do is we want to take the edges of these kind of jagged, not very nice edges, and we're going to smooth them out. So I need to deconstruct this mesh again. Deconstruct mesh. Deconstruct mesh. There it is. And again, it's review, but that's under the analysis under the mesh tab. So plug that in. The thing that I want from this mesh is I want the faces and I want the vertices of this mesh. The faces, well, that is, I can just get, is there a parameter for face? Mesh face. You get a mesh face parameter. The vertice is a point parameter. I'm just going to leave the face here. We're going to deal with that later. The point we're going to deal with a little bit more immediately. Okay, so turn that off, and don't really need that on right now. So I'm going to get the naked vertices once again, or sorry, not the naked vertices, the naked boundary. So I've got the naked boundary component right here. I'm going to plug my mesh into the naked boundary component. And so that gives us the boundary. This is something we've done before. We're going to explode this again. So just like the last step, we're now taking this, we're going to explode it because we want these vertices and we want to get the pull point component. And we want to pull our flattened list of vertices from our deconstruct mesh. We want to pull all of those points. So that goes into the P parameter here. And we want to pull those to our exploded vertices from our naked mesh. So the reason we're doing this is we want this to be in a nice clean list that is only isolated to the vertices of our closed polyline. So the data tree here for having all of those points kind of like we know that they're the points of this vertex, like we know they're the points here. So we want to kind of like get our flattened list of points and associate them with our naked boundary points. So the reason is we're going to use a polyline smoothing, and then we want basically to reconstruct the mesh with new points as our vertices. So we're going to just basically rebuild this set of points. Okay, so we're going to isolate those. So this is kind of the brute force way of doing this. We have like a lot of points coming out of this. I'm going to get my smaller than component once again. I think we can safely use a tolerance of 0.01. So about a centimeter, 10 millimeters, plug that in there. So smaller than, we're doing a lot of Booleans for this kind of thing. So what I want to do is get a cull pattern. So we're going to cull this by a pattern here. And the first thing I'm going to cull is I'm going to cull these points. So the first pattern is probably just a true, yeah, false, the default. But I'm going to cull these by our pattern here. Okay, so now we've now associated these points with our naked edge boundary. So we've kind of reconstructed these naked points here. The cool thing is now we can, if I set this down, so this is our polyline. I want to sort these points along a curve. So sort along curve here. That component can be found under vector, under the vector tab, sort point along curve. And the points that I want to sort are our points here from our cold list. So that's going to be our point. And I want to sort this polyline. So if we pay attention to our dashed wires and our straight wires here, dashed wires mean we're dealing with a data tree. So this is basically a grafted list of data. We want, and this is a flattened list of data. I need this to match each other. So I'm going to take this curve sorting and I'm going to graft that. So make sure you right click the curve here and right click it and set to graft. So now I'm going to take the naked edges and plug that in there. If you don't graft it, then it's not going to match your list correctly and this will be wrong. So the reason we're doing that is because this probably is not correctly sorted. So I'm just going to make sure that things are sorted right. And then I'm going to stitch this back together with a polyline. Okay, so polyline. And I'm going to plug point into V here for the polyline. And I'm going to right click this. It's by default, it's not a closed polyline. So it's not probably along this edge loop. It's not going to create a finished line. So I'm just going to invert that so that it's closed. So just right click the C, invert it, make sure that it's set to false. So I'm going to go ahead and save this so far, so anyone can catch up if you kind of lost yourself. Okay. So awesome. Polyline here. Okay, now we're going to kind of ignore this for a second and do a couple things over here. So our list of points, I want to create basically an indice, like a series of indices. So like I want to know, just like what we did with, we were using before the kangaroo component to get the index list. The thing is, I want them to combine. So all we have to do for that is I can get a list length here of the points, and then I can I can just artificially create this with a series. So I'm getting the list length of our vertices from our points, our mesh points. I'm going to plug this into the count. So by default in a series, it starts with 0. The step size is 1. And that's perfect for what we need because we're just counting, we're just creating a list of index values. So it's basically kind of a data table of our indices for this list. So 0 to 1938. And now what I want to do is I'm going to copy this col component here. So I want these indices now. So in our list, we've taken the points here. So now I'm just taking from this index table. I'm going to get my list of indices with that same, just by copying this col, and we're using the same smaller than component here to deal with that. Okay, so we've got that. We also have indices from our point index map from sorting along the curve. So now I've taken those indices and I want to get a list item. Since we've sorted them, we now need to, collect the indices here from our point index map. And we need to grab those indices. So we're plugging indices into indices that have been sorted. Okay, so now we have from our sort along, we're plugging in index map to our index. We're plugging col pattern into our index list because this is the list of indices. So this is an integer value. And I'm actually going to flatten this list. So this is going to give us, this is basically telling us the list. So when we're replacing our vertices down here, after we've smoothed out these polylines, we can replace it with the index. So this is super important. Okay, so we have our polyline. Now this is the fun part. We are going to use a smooth polyline component, which is super fun component here. It's under utility, under curve. So it's into the curve tab, and utility down at the bottom is smooth polyline. So what's cool is this uses a smoothing algorithm, I think written by David Brutton, probably, I'd assume so. I think it's a default Grasshopper component. You plug this into this polyline into P here, and then this will start to smooth it, right? So see, if this was our original polyline, this is now our so-called smoothed polyline. You could give it a strength from 0 to 1. Let's just leave this at 1. I leave it because I want this to be pretty smooth. And then you can give it a number of times to apply it. So it looks a little jagged still, right? Like this is this is using 1 iteration to smooth it. So if we want to give this some more iterations, right? Let's, give this a number. Let's try something like 15. Okay, so that's made it pretty smooth, right? So look how smooth that is compared. We've cranked the number up. So if we bring this number down, right, you can see it getting like 0 is going to give us just nothing. You don't want this to be 0. So I'm just going to set a control here so that it never goes under 1. Okay, so 1, that's going to be our lowest level of smoothing, but you bring this up, and the more you go, the more smooth it gets. So if you bring it up to like extremely high, you can tell that some of these get very small, like it greatly reduces the area of our curve. That could be fine. That could cause some issues depending on what you're after for fabrication or whatever. But yeah, I mean, basically you can kind of control this a little bit. I don't know, let's leave it at 10 for right now and just work with that. Okay, so we can see that that's super smooth. Got our vertices, we got our polyline. Okay, so now we got our new polyline. This is our smooth edges. So basically what we're trying to do is that, so you see the edge of this is these jagged, our jagged edge. So what we're gonna do is we're gonna take the faces of each one of these and we're gonna take those points, and now that face, instead of connecting it to our old polyline, it's gonna connect that face from here to that new polyline that we've created that's super smooth. So the next step that we want to give this is when we explode it. So let's explode it. So we'll explode that guy, and then we will use our, let's just cull the last item on the vertex, because I don't necessarily need the last one. So cull index. We have our vertices here. I'm going to cull index, so cull that out, and then I'm going to get the last item, -1, and I'm going to cull that. Whoops, don't do that. Okay, culling -1 here. So we've got those points. So what that is like when you have a closed polyline, the last index is going to be the same as the first index. So it's just it's redundant for us, so we don't need it. Okay, so I'm going to take these points and I'm going to pull them. I'm going to use the pull point again. So we're making a lot of use of this pull point component because it's frankly extremely useful. And I'm going to pull these edges. So this is our trim mesh. So remember, I pulled this, I dragged this all the way over from the mesh that we created to trim our shape with. And that's going to be the mesh that I'm going to pull this to. So that way it's always, our points are always going to live and exist on this, whatever mesh we're using to cut our geometry with. So now I'm just going to bring the points out of here. Okay, so we've done the work of, we have our index here, indices here, and I flatten that list. I'm going to do the same thing where I'm going to flatten these points. Basically what we're going to do is I'm going to take this list of points here. So these are our original vertice points from our mesh. I have the indices of which points to replace them with, and I'm going to take those indices. So that's from our items over here, and I'm going to replace, basically, I'm going to replace all of our points here with these points. So that's all we're doing. And then we have the indices to know which ones we're replacing with. So I'm going to use this replace items once again. The items to replace are going to be all of our point list. So again, that's just the points coming from our deconstruct mesh. So all the vertices from that are points that we're replacing. So we're basically replacing these points with these points. So these are going to be the points that I'm going to replace with. And then the indices are going to be this integer value coming from our list item of indices here. Okay, so now we can see that these points are included into our list of vertices. And the last thing that we're going to do is we're going to reconstruct, sorry, not reconstruct, just construct our mesh. So I'm going to get this component called construct mesh here. That's going to be found under the mesh tab. Under primitive, there's an option here where you have construct mesh. So this is just useful for us because we're basically recreating our mesh with our newfound vertices. So if I plug that here, all right, nothing's going to happen because we only have one face. So remember, I pulled these faces out of our original construct mesh, and I said we'll get back to these later. Well, this is the later. So I'm going to pull these faces over and plug those into our construct mesh. All right, and then that's all we do here. So I can turn everything else off. Maybe let's drag this preview over so we can just track what we're doing. Okay. So that's fun. We're already getting close. And actually at this point, with the smoothing our meshes, we could put this into Kangaroo right now. So I could use this. Remember we created this Kangaroo relaxation thing here. Well, I could drag this over and we could call this a day and just plug this in into our relaxation script. Just retoggle that and then have a smooth minimal surface, right? Like, yeah, I mean, now we could basically call it done. But one last thing that I like to do is I like to, you see how we're kind of spanning strangely from here to there. I like to add just another little set of faces here to give us a little bit more breathing room when we're smoothing this out. So I'm just going to disable this for a second. We have that plugged in. I'm going to drag this off. And okay, so we're looking at this. You know, this is pretty good so far. What's nice is we can change the smooth operation, right? We can make this more or less smooth. If you go up, it'll, you know, drastically shrink the size. So, you know, maybe you keep it a little low just for purposes of this. So yeah, so basically what we're doing is, because we're using the anchor points to get the smooth edges, we really do need this process here for the smooth edges. Like, there's other ways, like you can have some more advanced ways in Kangaroo to smooth the edges at the same time and then also keep them conform to the mesh. You know, it works. It's a little slower of a process, so it just kind of depends on what you need to do. That's basically kind of all I'll say there. It's just everything that we are doing is just highly dependent on like what your needs are. But for doing this kind of stuff, I think I like doing this because it's super fast, right? We can see immediately in real time, like how changing the smooth factor on our edges changes the smoothness, right, of each one of these outlines. So yeah, let me save this. And this whole thing is our smooth boundaries. So if we go back over to our, too many, our user objects here, this is the same equivalent as our smooth naked boundary here. So user object that I shared for smoothing the naked boundary, that is going to exist here. Okay, so one last step for us to do is I want to add some faces. So we're going to, so if I looked here at the user objects, let's see, offset naked edge here. So this is our offset naked edge. We're going to create this. So this is our last bit in our segments. So after we kind of build this whole script too, we will, we can string it together using just the user objects. I'll just I can show you how to do that. Okay, so this last step for adding some offset to our edges so that it's not, you know, so tight around the edge. Okay, same familiar process. We are getting our naked boundary, Weaverbird again. Naked boundary, we want this edge of our new created mesh. We want to explode our mesh, or our naked boundary, sorry. And we want the vertices once again. So you can tell this is kind of a common theme for building this kind of thing. dealing with the vertices, because basically what we want to do is we want to we basically want to take that and kind of loft it away from the trim mesh surface. So we have this trim mesh. I'm going to go ahead and copy this once again. Let's just follow the stream down here. So this is something that we'll be using for this. Okay, a trim mesh. And these points, I'm going to get a mesh closest point. Mesh closest point, our vertices. The reason that we're doing mesh closest point, because this gives us a parameter on the mesh, and I want to evaluate the mesh. So mesh eval. And the reason we want to evaluate our mesh with our trimmed mesh here is that we want the parameter from here. So location, we don't want that. We actually want the mesh parameter, and that is going to give us the normal vector, which I'm going to right click and unitize. I think by default, it's probably unitized already, I think with these, but just for good measure, we'll do that. And then I'm going to multiply this by some value. You could also do the amplitude. It's the same thing with the vector. I guess amplitude would probably override it, whether it's normalized or not. It doesn't matter. This is fine. So 1.50, 1.5. I'll just put it at 1. Just make it a meter off of the surface. So okay, right now I'm creating a vector. So what I'm going to do is I'm going to move these points. We're going to move that off of this trim mesh by this vector. So we're just going to get a move component and do that. So moving those off by a vector. And what we're going to do is, well, there's a couple ways to do this. I think the way that I did it in this component was I stitched it together. I basically made what is considered a mesh loft. But I think for just purposes of this, we could just make this we can do it this way. We can do it this way. Let's just basically creating a mesh loft. So what I need to do is I need to shift my list, because what I want is I have, so let me just draw this really quickly explain this. So I have a point. I have a point here. I have a point here. So let's say this is my mesh boundary, and this is a point, and this is connected. Like this is a mesh face here, right? And then it's so on and so on. So I've moved these points right off the mesh, like these are coming up. So I want to basically connect. So if this is my start point in this point list here, I want to connect this to this point, and then I want to connect this to this point, and then I want to connect this to this point here. So I'm trying to basically stitch this list of points together. So I want my first point, I want my adjacent point, I want the point in this that we've moved up off of this vector, and then I want the adjacent point to that, and I want to create a mesh face all from that. If that's confusing, then, well, sorry, but you'll see in a second why this makes sense. Okay. So we have this. I'm going to shift list. So I'm going to shift list on my point here. What that's going to do is, like in the drawing, it's going to get my adjacent point. And I'm just going to get a merge component. And some people say it's bad practice to simplify. I don't care. We know this is always going to be a data tree. So it's good practice for this situation. Okay, so I'm going to get a merge command, and I want to graft each one of these inputs and simplify. So I'm right clicking, I'm grafting it, and then I'm right clicking, and then I'm simplifying it. The reason I'm simplifying it is because sometimes down the road when you're doing these kind of operations, if you see this data tree, it's got a whole bunch of zeros in front of it, because any operation that you're doing, it's kind of adding segments to the tree. So if I have this tree down here, those zeros, if they're not the same amount of zeros matching from one list to the next, and you merge them, sometimes you get your list is mismatched or your trees are mismatched. And I don't want that. So this allows me to not deal with that. So this point from our explode, so if this is our mesh down the wire, this is our point. This is going to be the first input in our merge command here. Our shifted list, that's going to be my second input because you just, I'll do a sketch object. So if this is my first point and this is my next point, I basically want to, I'm shifting my list because that's going to give me, so if I'm starting here, the shift list is actually going to be this point. So that's going to be my next point. So I'm starting here, that's 0. This is 1. My moved point is actually going to be my last option because if this is my start, the point that I moved up is going to be this point. But I actually want this point here to be 3 in the list. So my next point that I moved, and then I want this to be 4. So, sorry, that's like 4. That's a 4. Sorry, it looks really terrible. You get the idea. Okay, so I'm going to shift my list again, but not that list. I'm going to take my move and I'm going to shift that list. And that's going to be 3, right? So this is that point. So this shifted list from our moved points is actually this point here. So that's going into data item 3. And then our move objects, that's going into data item 4. So yeah, I don't want that crap. Okay. So we now have all of these organized into what will now be our basis for creating a quad face extending off of this mesh. All right, so now all I need to do is get a construct mesh object, right? Just like we did before. And the face is fine. I'll leave the default face as it is. I don't need to mess around with that. And I'll plug R into vertices here. So if I turn everything off, now this is my new meshes that are the new lip. So this is what we're basically creating. This is going to give us some just like some extra bite to when we're smoothing out our minimal surface geometry. Okay, so I'm gonna do that just for good measure. I'm gonna clean the tree. I have this as a note. I don't remember what about the tree I needed to clean, but if I did it before, okay, yeah, there's something. Some of these are not going to create a mesh face, so we got to clean the tree. That's fine. Okay, so now all we do is we have our distance, so you can adjust the distance, how far that's off. This thing, like what we just did here, this is basically what, I mean, it's not quite the same, but it's essentially a similar concept to mesh lofting. It's kind of like, you can think of this as, you know, you're moving a polyline off of the surface and stitching it back together. Okay, so the last thing we want to do is we want to get a merge component again, and I'm going to flatten the input here, flatten this input, because I actually don't want these to be a data tree. We have a single object, and I am going to take the clean tree and plug that into merge here. So now we have all of these mesh faces as one list here. Drag my little preview over. We save this. So if you're following along, you can grab that and open it. Okay, so now I've been evangelized to the Pufferfish welding component. So we're going to grab that component again. Rebuild. Let's rebuild our mesh. So this is going to allow us to weld it and to join it. So take that, and just so we can visualize this better, I will put that in here. Turn everything off we don't need. Okay, great. So we can see it is not welded yet. Unify normals, I want that to be true. Used, build, we don't really need that stuff. So reverse, we don't need that. Okay, in case you want to do this, we'll have that, and then weld, we'll give that a parameter. I'll just keep this as a param and unplug 001 so that the tolerance is in a millimeter. Okay, that's not welding. Oh, it's not welding because we need to join it. Sorry, skipped a step. I got too excited about this pufferfish component and I skipped joining us all together. So we're going to join this mesh and I'm going to plug this into here. There we go. Like, why is that not working? Okay, so I want it to weld, and just in case, I'm going to turn this on in case you need it. You can plug that to true, and now we have a nice clean mesh coming out of here. Okay, so that's our new mesh, and let me just look at this and make sure that we have a mesh that all the normals are consistent. And it appears as though they are, and that is perfect. It's exactly what we need. Okay, and now we are finally at the end of the road here. So we've done everything that we need to do. Let me just, I can delete that thing and enable this. And now we can have our smooth minimal surface geometry here. All right, I mean, that's the workflow. So go ahead and group this. One last step that I'm going to do is our output here. We have our relaxed mesh. So the last step that I want to do is I want to turn this into a sub D object. So I'm going to go to my surface command here and sub D from mesh. And now it's really nice and smooth. Add that to our group. And then for good measure, I'm just going to get a sub D geometry type out of here so we know what we're doing. Add to my group, and let me just group that too and color this to my baking colors. All right, so now we have our sub D object, we have our mesh. So Arwa, to answer your question, I'm about to show you how to do that. So bear with me. We are about to take a sub D shape and we're going to use that to trim this. But basically it's the same process. So instead of, just to kind of quickly field what we're about to do is, so we use the box, right? So we're using this original box shape here. And instead of using that box shape, what we can do is we can take an input sub D we can run it through this, or actually we don't need this part. We can just run it into our mesh from sub D, turn it into a mesh, and then use that for our trimming shape. So yeah, that's all we're gonna do. So yeah, this is that process. So just quickly, right, we can play with these parameters. Sometimes it's better if you double click it instead of dragging the slider like I was doing. But yeah, you can change these parameters, and they will. Let me just go into a rendered preview so we can see a little better here. Yeah, and they'll update in real time your surface. So one thing just to keep in mind when we're using like this output component, sometimes because it's in a cluster, sometimes you have to restart it. You have to refresh it from time to time. I don't necessarily always like to put the kangaroo stuff in a cluster for that reason. One thing that I could do is just explode the cluster. And if I do that, maybe it's a little easier to work with just typing things in. So yeah, you can change the number of points. If I wanted to change this to a much higher number, like 60 points, I can do that. And just keep in mind, the more points you have, the more geometry you have to work with, the slower that this will go. It works. Definitely, like, this is pretty much real time, but you can see that it just takes a little bit longer to calculate. So just keep that in mind when you're designing with this or using this kind of workflow. Yeah, so I'm going to keep this. I'm going to lower this again to something like 25 is good. Okay, let me just save this. So that whole process here is we have it. You can play around with these values and, generate different shapes from this. Changing the scaling is going to change things about your shape. Changing this value, like if I change this to something much larger, we're going to get fewer segments in our shape. If I change this to a much lower value, you're going to get more segments. So it really is just kind of about tuning and getting something that you feel comfortable with or like aesthetically. Or if there's other kind of criteria that you need to work with, right, you can kind of think of ways to plug that in. So yeah, we're only smoothing this by 3. If I smooth this by 18 or something, right, my edges will become much more smooth. So it could create, some nice, it's definitely a cleaner edge when you have the edges turned up like that. All right, so maybe this is a geometry that I want to work with, right? Like this is one. So in our example file, maybe I'll make another label or another layer. I'll call this something like sphere sub D output. And I like this. So I'm going to go ahead and take this sub D and I'm going to bake this to, maybe before that, I'm just going to make sure that this is converged correctly. Just to make sure it's the minimal surface that I want. And I'm going to go ahead and bake this to the layer I just created, sphere sub D output. All right. So yeah, that's great. Now I have this sub D object. I think for the most part, it's entirely based off of quads. So that's one thing I like about this workflow. I'm not dealing with, a lot of triangles or anything. It's got pretty much all quad faces, which is nice for the next part of this workshop where we can take this into Pufferfish and use that. Before we do that, I'm just going to go through a couple more methods here on. So we have our components. So I'm just going to show you really quick the process to kind of recreate this just using. So we've done this whole thing here, but you can recreate this using all of the clusters that I shared as user objects as part of this workshop. So let's just do that really quick. So I'm going to save this, and I'm going to disable my input box here, so that way just this geometry doesn't show up down the pipe here. Okay, so if you were to just recreate this whole thing that we just did with just the user objects that I shared, let's start with a box the same way that we did before. We would then go to our Voronoi mesh network. So input geometry is going to be our box, and then scale value, let's just give this 0.95. 1.2.00. I'm just going to recreate some of these sliders, scale the Voronoi bounds, scaling our point bounds, number of points. I can do something like, put 30. Random point seed, let's start with 500. Scale cell faces. So we know the output of this is a mesh, so I'm just going to grab a mesh so we can see. So right now, because we haven't finished our inputs, it's not going to give us any output. All right, so 0.500, I'm going to copy that. And then 2.00. All right, yeah, I'm just recreating sliders right now. So once I plug the last one in, now we have our Voronoi mesh network, just like we had before, and it's all basically in one component cluster that we've used. Okay, so that's first step. The next step is to rough trim our mesh. So the trimming sub D, what we do have to do is we have to come over here and recreate this process. I think I'm making it a mesh inside the component, so we just give it a sub D. So I'm just going to copy this. Basically, all I'm doing is turning this box into a mesh box and then turning it into a sub D object. So sub D, we can actually, so to answer the question before, like this is how we're going to do this. We're just going to replace that with a input sub D. So if you have an input sub D, yeah, I'll show you how to do that in a second. Okay. So that's our mesh. Our mesh to trim is going to go into there. Subdivision density, I'm going to just give this a 5 like we had before. And then 1, 2, 3, that's just our quad subdivision numbers. We're going to do 1 through 3, and I'm going to give this a value of 1. Okay, and now our mesh output from this, if I turn all of this stuff off, that is going to be our trimmed face mesh that we had before. Okay, so the next step here, we've done our mesh network, we've done our rough trim. Now we need to cull non-manifold vertices. So that's going to be our input mesh here. give this a, I think we don't actually need the tolerance. Okay, so that's cleaned up our mesh. So that's cold non-manifold. The next step along here is to smooth the naked boundary. Just get another mesh parameter out of here. Okay, so we don't have iteration, so iteration's 12. Okay, so that's already smooth. Bounding mesh. So if you don't use a bounding mesh, so this component actually gives us the option of whether to use a bounding mesh or not. If you don't, it's a little less predictable, but you might actually like what that gives you. But just to put the bounding mesh, we can just create our mesh from the sub D here. I guess this could be a little more consistent with how we're doing this, but for this, let's just use our mesh from sub D. That's our input sub D. Okay. I'm going to plug that into our bounding mesh. So now it's definitely conforming to our original bounds mesh. Okay, and then back to our user object. So that's smoothing it. Let's give this an offset, our naked edge here. So that into the input. Boundary mesh is going to be this. So we do need that for this component. And an offset distance, I'll just do 1.200, plug that in, and now it's outputting a mesh. Okay, so, and now you can use this, the relaxed mesh user object. So input mesh, length factor, all of that stuff. I have that all over here. So I'm just going to copy some of this stuff, so I don't have to reset all of that. Coming back over, input mesh. Button is going to be reset. Threshold is our threshold. Length factor 0, and then run the simulation. That's going to give us a mesh that is a minimal surface. So basically, we just took all of these, basically all of this stuff, this long definition, and we've converted it into user objects, which is kind of a nice advantage of having user objects for certain kind of operations. I mean, you could theoretically turn the whole thing into one user object, but it can get a little cumbersome that way. So now we have a user object from our relaxed mesh, and we have our minimal surface. So we can turn that into a sub D object, same way we did before. Sub D from mesh. And I can get a custom preview. Yes, so to give a thickness, there's multiple ways to give thickness to it. If you want to make it thick before you turn it into a sub D, we're gonna go over that at the end, but just quickly, let's use a pufferfish offset mesh, and I'm gonna plug in. You can just plug in mesh to offset, and then give it a distance point. I don't know, 2.5 meters thick. You could do, if if you wanted it to both sides, you give it another number. You just give this a negative value, and that'll go both sides. I mean, the beauty of this, I think Mike changed this a little bit to where you could give it specific values in case you want to offset it one side more than another side, which is pretty useful depending on what you're trying to do. I don't care right now what it is. So if I want to do it both sides, then now I just plug that into the sub D object, and now it's given some thickness to my sub D. And maybe that's, excessive. So I'll do 0.1, get a little thinner. Awesome. So yeah, that's how you would add thickness. I think for now, I'm just going to keep this unthick because we can kind of prepare that in the end. Because right now, I just want to work with this shell geometry. Okay, so now just one more point to go over, and let's look at our base sub D examples. So I'm going to use this this script here that we just did, and now to make this so that instead of using our box, we can use a. Let me just copy this stuff down here. Just gonna copy all of this. This is how to do it with the box. If I save this, and let me just disable that. Let's input a sub D object. So I'm going to take a sub D. I'm going to right click this and set one sub D. So right now, this is what we're using as our input geometry, like a B-rep from the box going into input. So I can actually directly plug my sub D into this. But before I do that, let me disable my solver. I don't want to screw anything up with this. Make sure this is going to work together. So I'm going to save this file, save this file. So don't want anything bad to happen. So, okay, I'm going to plug my sub D into my input geometry. Right now, the B-rep, I'm turning it into a mesh box, then a sub D, and then a sub D. Well, if this is our sub D, we don't need this anymore. I can delete that. So that's why I made a duplicate of this. I can delete my input box. I don't need that anymore. So I have my input sub D. I'm going to plug that into here. And yeah, that's all you have to do is now you make that a mesh. And I will enable my solver, and this will recompute to be conformed to our input mesh here. So that's what's great about this workflow is it doesn't matter if it's starting from a box or not. You can like literally feed it any sub D you want, and it'll make a shape from that sub D. Okay. So let's just play around with this sub D thing for a second. So the cool thing, I'm just going to copy this sub D over here. So the same way, just to recap from what we were doing with meshes earlier, you can control shift, hit control, hit shift, hold those, and you can move the faces around. I can use the gumball to even further rotate that. If I wanted to, I could play with vertices specifically if I wanted to. I could extrude this face out, make another face here. One cool thing is if I wanted to, let's say I wanted to mirror this geometry, and I have these two faces. Let's say I want to connect this face to that face. So one cool command that I can use is bridge. So let's use the bridge command. I'll set this face. Okay, hit enter. Second face is this face, hit enter, and now it's going to bridge between those. So you can choose to crease it. We don't need to crease it. We could choose to join it. That's what we're going to do. You can play with the number of segments. I'm going to leave the default to 1 segment and just hit OK. And now I have bridged this shape. So, once you have this, you can also, mess around with it. So what's cool is any sub D shape, whether it's, this kind of shape or this shape or whatever, well, now I can set that as my input shape. So if I set 1 sub D, that is now my new input shape, and we can, work with this thing. So this kind of creates this funky minimal surface thing just from that. Maybe I want this to be squished closer together. There's a lot of things you can do. Maybe I want to bridge this face to that face, so I could bridge this to that. Oops. So as you modify this and it's plugged in, it's going to recalculate in the script. All right, so now that's kind of created this other condition here. So if I turn that off, I can see what that begins to look like. Oh, and if that happens, it's probably because this needs to be reset. No? All right, well, we found an error here. Well, never mind that bridging, that didn't work. Always something. So that's the first time I've encountered that, something I'd have to diagnose, but it should, for all intents and purposes, work for every situation. Let's try bridging this. Oops, I don't want that. Great, that works. That's something we'll just play with this and use that as we kind of proceed with this thing. I'm just going to go ahead and it's like too high for me. So just FYI for the image, I don't know if you saw, but I did an image yesterday. So this image here, this was created off of this shape here. So basically this was just using the same definition. I baked it out and I used this shape for that. So I think for this, maybe let's use this shape that this funky thing created here. Yeah, I think that will work just fine. Sometimes, I could spend hours just tweaking parameters and like making things look the way that I want them to look for whatever purpose. Like it just depends on what you want. I'm not going to go through that, but maybe I will change a couple parameters. Like you'll notice if you change these down, and change that up. Like sometimes that just gives you a different relationship for how the smoothness looks and appears on your surface. So it really just depends on what you're going for. Like maybe let's change that. So turning it into a solid, that's what I showed here with the offset. If that's what you mean, that's going to create a solid geometry. I think for this workflow, I mean, it has to be tested, but yeah, conceivably you can, if you don't want to use the Voronoi network, you could like plug in really anything. Like you could use a gyroid, minimal surface tessellation. You could use other types of tessellations. Doesn't have to be Voronoi at all. Like you could use really anything that's kind of does a similar conceptual thing to like this closed mesh type of network. And it doesn't even have to be, well, it doesn't have to be closed. Like this is an open mesh actually. But yeah, I mean, this could be, you could just array boxes and then do the same thing where you're scaling the box spaces down and get results from that. Where it might be a little more, that might give you something more regular on the inside, but then it's going to give you kind of a more smooth geometry on the exterior, right? So it just kind of depends. And then maybe for this, I want this 3, 5, just. Okay. That's kind of cool. I like that. Maybe I bump this up and try to get rid of some smaller faces. Cool. Don't have anything glaring. No glaring issues here. All right, awesome. So let's just say for all intents and purposes, this is the, yeah, so you can create a lot of patterns. We're actually gonna, that's the next part of this, is we're gonna go through how to use Pufferfish to pattern this. But yeah, I mean, you could give it patterns from lines if you wanted to. Yeah, I'll show you the Pufferfish workflow though, and I think you'll be happy with that. Okay, so we've done our sphere output sub D. Let me just duplicate that, and instead I'll call this something like, I don't know, form output sub D. I don't know what to call this. Okay, so I'm gonna bake this to that new layer I just created. Also, by the way, for this, in the example files from the share work site, everything that we've just done, I have created an example for this as well. So this is, yeah, if you open up these examples, it'll be also everything that we just went over. So yeah, if I open this file, it's documented. So this is everything that we did. It starts with a box, but this is, you can change it from a box input to a sub D input, and it'll change your input sub D. So if we were to take this and now use our base sub D, set 1 sub D. All right, it's going to work on that sub D object. So yeah, if you want to play with this, this file is like documented. It tells you the steps and all of that. And that's true of other things. So I think this is a good time. It's 2:30 here. This is a good time to take a little break. So let's take uh let's take 10, come back at 2:45. We'll run through I'll run through the box morph example really quick, and then we can basically what the next thing what we're going to do is if I look at, you know, this image that I shared, we're basically going to create this pattern using box morph. I have the tiles already created in the example file, so we're not going to bother really creating it. And yeah, we're going to tile this shape with that, and we're going to put this into Blender and render it. Okay, so I'm going to save this off. So these should be our shapes. And yeah, let's take 10. 2:45. Okay, I'm back. Okay. So, welcome back. Just a little 10-minute break. Okay. So for this last section, this is our last section in Rhino. Let's reference this picture. So basically what we're going to do is we've made our minimal surface geometry. We have done that. So the next step is to take a pattern and populate our mesh with that pattern. So we're basically going to take these meshes and we're going to populate it with these things. So you can kind of follow, like, I'm not going to recreate this because I've already, created it for purposes of this workshop. Let me just center us here. You can see from the base curves, like the steps that I've followed to kind of create these patterns, or these panels. So essentially what we're going to do, let me just kind of mock this up in Rhino really quick, just to show us what we're doing here. Let me just delete that. I've kind of created a panel that's creating this, what they call a trochet tile or truchet. I don't actually know the correct way to say it, but I say trochet. What the trochet tile will do is if I have these kind of, just group that, I have these set of tiles and I copy them in a grid. The default, right, these all kind of continuously create a sign, like a curve continuously together. But as I rotate, what I could do is I could randomly rotate this by 90 degrees. And now it's going to create, it's going to open up a new direction for my curve. So you could do this for any number of these and just randomly start to rotate them. And it's going to give you different patterns based on that rotation. So the nice thing is that it's always touching at the midpoint of the grid. So since we're always touching at the midpoint, it'll create a different like wave type of pattern just by rotating it. So that's essentially how we're going to treat these tiles. And I am using Pufferfish. We're going to use Pufferfish to basically tween between this mesh or this sub D object and this sub D, this open sub D over here. So, if you follow the steps for creating this, you can kind of see what I did. I created a sub D with a face structure like this. I used creasing to crease the edge. So we could tile it with one single tile with really any one of these tiles. But what I want to do is I want to use an attractor geometry to basically tile between one that is much more closed to one that is much more open. So it's the same method that I used for this image here. Okay, so the basic way that we're going to do that is we're going to take our sub D object here from Rhino. So I guess let's just go ahead and use this one I've created. If you've created your own, just use whatever one you've created, or you can also use one of the examples that I've already saved in here. Okay, so let's go ahead and just going to disable this stuff. So enabled. Okay, So this is our working definition. So now what we're going to do is we're going to take the sub D object, and I'm going to use a sub D input geometry in Grasshopper, and I'm going to set one sub D object. Okay. So let's just set up a quick morphing box morph situation here using Pufferfish. I'm just going to use like a simple panel at first. So just to get the concept out of the way, I'm going to go over to Pufferfish right here. And first I want to turn, so like we've been working back and forth a lot between sub D and mesh geometry, but I'm going to change this back to I'm just going to use Grasshopper and go from a sub D back to a mesh. Okay, so by default, this is giving us a lot of faces. So what I can do is get a slider. And actually, let's just keep this at 0 because I just want kind of the outer edge for this shape. Anything more than, if I start subdividing this more than that, this could start to get extremely heavy on us for the workshop purposes. So I'm just going to keep this at 0 right now. And then I'm gonna weld this mesh. I think the default welding strategy should work. And let me just turn off this geometry here. Okay, so we have our welded geometry. We want to use Pufferfish basically to get, we have this as a mesh. I think they have tools for, there's tools for sub D, but yeah, I mean, you can use the sub D too. I'm just going to convert it to a mesh right now because that's kind of a workflow that I'm used to. So let us, from the mesh, or actually we want twisted box. So in the twisted box tab, we want a twisted box from a mesh here. So it's under twisted box and Pufferfish, twisted box mesh. Okay, so everyone can hear me fine, right? Just saw that I lost. Okay, awesome. Thank you. So I'm going to plug my mesh into this twisted box. No problem. Why are you yelling at me? Okay, so a twisted box, and the thickness by default is at 2, so that's going to be 2 meters. I can set this down to like 0.5. And then also, when you're looking at twisted box, I mean, this is an amazing thing. I think Michael really outdid himself writing Pufferfish and all the inputs and parameters that you can play with. I'm just going to keep this more simple because we don't need to stack geometry for this. We can go ahead and just do a, I'm just going to get a range component. Wasn't there a shortcut, Mike, that you could just plug in 1 here or something? Yes, cool. Also a shortcut that you can just plug in a parameter of 1, and then it's automatically going to, give us a single output volume here, which is great. So yeah, now we have these twisted boxes that we're using just from our mesh faces here. So I'm just going to plug in one of these sub Ds. I'm going to use one of these earlier options actually, instead of the open face option, just so we can kind of see what's happening. So I'm going to get another sub D, and I'm going to plug that sub D object, set one sub D. And I'm going to use in the transform tab, I'm going to use morph to twisted box. So the geometry to morph, that's going to be the sub D geometry. The reference box, I'm going to create a bounding box for my object here. If you model this cleanly and confine it to a rectangular grid, this should be not a problem. So yeah, I'm just going to use that as my reference. And then the target box is going to be the twisted box coming from the Pufferfish twisted box mesh component. So that's going to morph all of this panel directly to my mesh. And this takes a little bit, especially since this is so CPU heavy in Grasshopper. Okay. And I'm just going to turn that preview off. I'm going to get a sub D geometry, and I'm going to turn the preview off of that because it takes a second. Show the preview. Okay, so one thing I could do is maybe I'll just bake this just so we can take a look at it. Okay, so now we have baked that panel to our sub D. So, right, this is basically taken this panel here and it has morphed it to our sub D object. So maybe a good way to look at that is the rendered viewport. So yeah, that's pretty interesting already. So we've morphed all these. If I wanted to, let's say, join these, I could, and this is really the process. There's not really a good way to join sub Ds in Grasshopper. I mean, it's possible, but it takes a while. Like it takes a while in Rhino. So this might take a second for this to join. So, you know, full disclosure, when I did this level of subdivision with this shape here, I'm not going to go that subdivided just for this because this took quite like several minutes actually to join together. So I'm not going to deal with like a ton of geometry for this, but right, like you can see that it's taking a little while. I mean, this is another reason that you probably don't want to be joining this thing in Grasshopper anyway, just because it's such an intensive process to undergo for your computer. But I'm just going to wait for that. And maybe because this is a slower process, I might use a geometry with fewer faces just for the demo, because this might be untenably slow. Here we go. Okay, so now we have joined them, but this is what we want because now joining these together, it's completely smooth. So we could see before there was a facet in between, and that was due to just the fact that it was panelizing on it. But now that we've joined it, this thing is totally smooth, and it's creating that kind of truchet tiling that we were looking for earlier in this example here. But we haven't actually created it with rotation at all. I mean, there is some rotation just by virtue of how the mesh faces are oriented. But if we want that, we have to build that into the script. So I'm just going to save this as an example pattern layer, and I'm going to go ahead and change my object to that. So I know I was using, this is probably a more interesting sub D that we're using, but I'm going to go ahead and use this one for the demo just because it's going to take less time to do this stuff. So let me just set one sub D there. Yeah, you see that's already taking less time to calculate. So one thing that I want to do is I have my sub D objects, I have my bounding box. I'm just going to set up a little I'm just going to set up a little thing where we're taking this and we're going to create it like a crochet pattern. I think one way I could visual this is oh no, that's going to be super heavy too. Okay, never mind. It's not going to not do that. Okay, so we're going to set up an operation where it's going to rotate this a bunch of times, and then we can deal with really getting these things so we can tween them together. Okay, so the quick way to do this is we have our sub D, we have our bounding box. What I want to then do is I want to get the volume of the bounding box. So that's going to be our center of rotation when we set up a rotation function on this. And for the geometry, I'm just going to get the length, the list length, because I want to know how many panels that I have. But really, it's the list length is going to actually, yeah, let's get it from the twisted box. So I get the twisted box here. I want the list length of my twisted box actually. And move this stuff over. So I'm going to create a random. So I'm going to get random numbers. My domain, I can leave that at default 0 to 1. I can right click this and turn this into integers. So the number of random numbers is going to be here. So basically, I just want to convert this now from zeros and ones into 0 degrees and 90 degrees. So sorry, I'm in the US, so I use angles, not radians much. I think it is pi. Okay, I'm going to use degrees because it's easier for me to think about it as degrees. And I am rotating this, each one of these panels. So I'm going to rotate in a plane. That plane is going to be my volume center, and the angle is going to be not this. If I were to do this, it's just going to turn that to degrees. It's just going to give me 2 of nothing. So what I'm actually going to do is get, this is going to be a list item. So I want to get the list item of my list is 0 and 90. So I made a list 0 to 90. Let's make sure that multi-line data is unchecked. And I'm going to plug in, these are going to be item indices for the list of 0 to 90. So 1 is going to be 90, 0 is going to be 0. And that is going to be my angle that I'm rotating. And I'm going to rotate this sub D geometry. And sub D geometry always takes a while to show in the display. So just going to turn that off. And then, yeah, so this might take a second. Rotating that. I'm going to get the bounding box again of all of these geometries. I mean, you could do it from the same bounding box here, and it will be quicker. But since we're going to tween these, this is going to be a factor later that's going to cause problems. So I'm going to plug the bounding box into there and then plug this into the box into there. So let me I'm going to disable my solver. Just middle scroll wheel, click disable, because this is now going to be the sub D geometry that I'm using, and this box is going to be the box that I'm using. So this will be the same number of boxes, 1764, as our twisted box. So goes into there, and that goes into there. I'll turn this on, and yeah, that should be good. So let me go ahead and now bake this, and we can see what that looks like. Okay, so now I've baked it, and now we're getting that nice trochet effect that we were looking at before. Go ahead and save that. So this it might take a second to join, but it should take less time than our last example, just because there's going to be less geometry. I'm going to leave it to smooth. We'll see how long this takes to join. Great. So now we have joined it, and it's kind of created this interesting crochet tile pattern. So perfect. That's exactly what we want. I'm going to duplicate the layer, call this example pattern 2, and change that object layer. Let's turn that off so we have a record of that. Okay. So now what we want to do is we have this panel and we have this panel, and we want to create basically a tween between this one and that one. So I'm just going to keep this stuff over here. Let me disable that. I'm going to copy this down just so we'll keep a record of this. So that works. And then copy that, and we'll keep this around just as something to play with. So turn that back on. Take a second. Okay, awesome. So now let's go from this panel to that panel. So I'm going to get a sub D object, set one sub D. I'm going to get another sub D object, and I'm going to set one sub D. So now I have my two sub Ds. I have my first one and I have my second one. So this is going to be my more closed off one and my more open one. Okay, so the thing that we want to do is we want to use Pufferfish to what's called tween between these sub Ds. So Pufferfish 3 has these awesome components for doing that with sub D, which I think they're user objects, but it's basically like turning it into a mesh and then tweening that and then stitching it back. But I'm going to use these. So tween two sub Ds. I'm going to get this component. Oops, did not do that. Okay, let's take sub D1, plug it into A. I'm going to take sub D2 and I'm going to plug that into B. Okay, so by default, now we have this sub D object. So if you notice, geometrically, this sub D has creases in it. So I've taken that, and not only does it have creased edges, but it has a couple of creased points. So this one does too. And I want to maintain those creases. So what's happening when I'm tweening it by default is it's actually removing the creases and just smoothing out my geometry. I don't want it to do that. So we'll deal with the factor in a second, but the crease type, that's what's going to be determining this. I want this to equal, I think 1. We'll do 0.2 just so we can look. So crease type 0, 1 is going to crease it at the whatever the crease was, and then 2 is going to crease it at the edges. Well, I don't really need the edge crease, so I'm going to keep this at 1. For corner creases at 0, it's not creasing the corner. So I want this to, and actually I don't think it is going to crease the corner because there is no, it's not a corner, right? This is actually creating a non-corner condition. So I can do corner all I want and it's not going to do anything. Okay, I don't need that. So, all right, so it's created this crease, but if I just copy this geometry here and we take a look at what's happening, I have this corner, I have this vertice creased, and I have this vertice creased. So if I were to remove the crease, but then maintain that crease, so just crease that geometry, right? This is what it's doing. It's still creasing the edges, but it's not creasing my vertice. And that's annoying because I want it to also crease the vertice. I just want it to maintain that the same thing that my input geometry is doing. So unfortunately, Grasshopper by default now, as it exists, does not have an option to maintain that crease. I don't know why that is not built in, but you can fortunately use scripting to do that for us. But to do that, we also need to kind of figure out exactly what points we need to crease. So that's what we are about to do. So let's take a look at this side of the geometry. Oh, also, by the way, for the factor, I'm going to get a range here. Range. And the number of values, let's just get a slider for 12 so we can bring that up if we want to. And 0 to 1 is good. We want 0 to 1. And I'm going to plug this into the factor. So that's going to give us a factor. And let's just turn this to, let's just put it back to 10. Okay. So the reason these are so far apart in the file is just so you can see this a little better. It just helps us visualize what's happening here. So sometimes I'll pull that apart just so I can see the difference between what's happening with the tweening. Okay, so right now it's smoothing it out for us, and we do not want that to be smooth like that. We want to isolate the creasing. So the way that we do that is in the surface tab, we can go to sub D. We can get the sub D vertices. So it does give us the option to get our vertices. So if this is our sub D vertices, and then if you look at this, it gives you what the points are. It gives you an index identifier, and then it gives you the tag, vertex tag type, whether it's a crease, whether it's a smooth corner. So we basically want to tag everything that has a crease. So, or actually we want it to be, technically we want it to be a corner, I think. Yeah. So I'm going to get a panel, and I'm just going to call this corner here. So this text tag type for corner. And what I want to do is in the text, where is it? Yeah, so under tree, the tree tab under text, we want to get a component called text distance. And what that does is basically going to compare our text and make sure that this text is equivalent to this text. So we're kind of using this text tag of the creases to compare this to the distance here. So now what we're going to do is we're going to get an equals component. Equals component. We're going to make that equal to 0 because we want that distance. 0 is going to mean that this corner equals that corner. And then it's going to, we're going to be able to dispatch our points based on that. So I'm going to get a dispatch component and put the point into the dispatch and grab my first point here. And now that is going to give me the points exactly that are these crease points that or corner points that I want to use to crease my sub D. Okay, so I did it for my first one. So we're going to use a combination of things here. So I'm going to do this. I'm just going to copy this little snippet and then I'm going to put the second one in here as well. And then I'm going to go back to Pufferfish. And with Pufferfish, I'm going to go to point and I'm going to tween 2 points together. So I'm going to use the same exact factors that I was using for this because basically we want to go from these points to those points. And then one other thing I'm going to do is I'm going to graft this point and I'm going to graft this point and I'm going to plug this point into there and plug this point into here. So I'm grafting the points and I'm twinning. So now that is giving me the points between these ones to those ones. The correct setting for joining in Rhino is I keep it smooth. So when you if you keep it to crease, it's going to join it and it's not going to smooth out the geometry like how I had it. It's going to keep the panel edges creased. So it kind of defeats the purpose of joining it. In our case, like it doesn't always when you're joining, but I think in the case of this, you want it to be smooth. Okay, so between these points, so now if I get the list item of each of these points, I see now the list item is actually all of these. So that means that our data tree is not how we want it. I want the data tree to actually have all the points. All of these points here should be in one list. So all we have to do here now is flip matrix. I'm going to flip the matrix. So now if I get the list item, okay, so this is the first item in the whole list of points. So that's great. I don't need the list item. I'm just using that to demo. So we have our points. These are our points here. We have our sub D objects. So this is a sub D. The last thing we want to do is we want to use so this is a user object that I've saved. So this is the last user object that we have here. So it is something you'll need, but this user object is sub D vertex crease. So just go ahead and go to the user tab. If you've dragged that in here, it should be in the continuous formations. So this is a C# script. Actually, I didn't write this script. I got this from the McNeel discourse forum. Oh, geez, why is this happening? Okay. So this was from a couple users, Silvano and Lasat, and that were our Rhino users in the discourse. So if you want to see the thread where, I picked this up, I adapted it a little bit for this, but I didn't change the fundamental logic of it. But if you're interested in this at all, to go deeper into this, you can go to this link on the discourse forum here. Okay, so what this is going to do is it's going to now take our points and here, and it's going to crease our sub D based on that. So first thing, the points I have in a list of points, it's in a data tree. So let me just graft. I'm going to graft my sub D output here. So this is also in a data tree. I'm going to plug the sub D into sub D, and I'm going to plug the points into points. And let me just get a sub D object to come out of here. And let me turn that off, and beautiful. So now what we have done is we have tweened using these awesome pufferfish components, and now we've got our corner creases, and it's tweening the geometry and maintaining our crease objects. So that's exactly what we wanted to do. So this kind of gives us now the basis for the objects that we want to then move on to our pufferfish tessellation. So I think for purposes of time, I'm going to save this. I'm going to save this file. So just FYI, we are going to be running a little bit over on this. So thank you for bearing with it and sticking around. So yeah, we'll go a little bit over time, but I think it's good. You'll see the whole workflow. But for brevity's sake, I'm going to just open one of the example files in here. So I'm going to open a document. So the pufferfish panelization is basically the thing that I just showed us doing. I think that's kind of like the important technical thing. The rest of this is also dealing with attractor geometry, things like that. So let me just go ahead and open this file. It might take a second to load just because it's thinking. Okay. So everything that we just did is here, and I'm tweening this by like 30. Yeah, by 30. And then the geometry input is, yep, so I am using this geometry, so it's the same geometry. A difference is I'm using an attractor geometry, so I'm using some points. There's an attractor layer with 2 points in my document. The attractor could be anything. It could be points, it could be a curve, it could be surfaces. It doesn't really matter. It could be a number of things, right? It's an attractor, so. But I'll just walk through quickly how the attractor is working. Basically, I'm taking the mesh face. So once we've turned that into a mesh, we're getting the faces and we're pulling that to the attractor. We're getting the distance, and I'm remapping those values based on the range of the number of my base modules. And I'm using that as like an integer of index values. So we're getting basically the indice value and getting each one of these sub D, it's a value from 0 to 30 as an index. And I'm getting basically the indice based on the attractor. So whatever is smaller is going to be closer to the attractor. Whatever is a larger opening is going to be further away from the attractor. Yeah, so this is also then going through the process of randomly rotating the same way that we were doing it before, and then using the the twisted box mesh, same way that we were doing before, and using that as the morphing, morph to twisted box for the geometry type. So yeah, the only thing that I'm not just covering in detail is this attractor step, but you can come in and see the logic and how I do this in this Pufferfish panelization example file. Cool. So what I want to do is now I'm going to duplicate this layer and call this example 3. And since this is already here, I'm going to go ahead and bake this. So let me make sure, yeah, that's at 0. I'm going to turn this off for a second and then bake this geometry to my new example layer. So yes, we'll take a second to think. Turn the preview off. So yeah, this is what the output will do. So once you've baked this, we can just now use that join process. So I'm going to go ahead and select those. And I'm going to, let me save this real quick and save this. No, I don't need to save that. And I'm just going to go ahead and join. And I'm going to leave it to smooth and press enter. Okay, so it'll take a little bit to join this. I mean, you don't have to join it either. If you don't care that it has some facets on the edges, but because this is continuous formations and not faceted formations, we're going to join this and make it smooth. So one thing that happens, at least in my display, is when the sub D, I don't know why, but I think probably when a sub D object is super large, it kind of has trouble displaying it. It is actually smooth. Like if you were to convert this to some like a NURBS or something, which I don't recommend doing because it's gonna be very heavy. You could try it if you really want to go down that route or need to, but for this, we don't need to do that. We're going to convert it back to a mesh, but yeah, this looks faceted. It's still a sub D representation, but let's look at the rendered view. So rendered view, it's going to be like this. So basically what we're looking to do is both sides of this. This is going to be we're kind of treating one side as smooth, the other side as faceted. Not faceted, but it's got our pattern placed on it. So just, I mean, keep in mind too, like the pattern could be, your module can be whatever you want or design. For this is just one that I happen to design for purposes of this. So we have that. The last step for this, it's like once we have this, so I'll go ahead and save that. Really, we just now need to convert this into a mesh and place this into and output it so we can put it into Blender to render it. So yeah, let's go through that really quickly. The last step that I usually do is I have that actually in this Pufferfish panelization file. So, same things that we've done before. We turn it into we turn one sub D into a mesh and we thicken that. And then this sub D is going to be here. So right now it's disabled. I'm just going to set one sub D. I'm not going to re-enable it. This sub D, I'm going to set as this sub D. So set one sub D. Let me turn that back on. Okay, so I'm going to turn both of these off. I'm going to save that and I'm going to save my file. And I'm going to go ahead and I can select both of these. I can middle mouse scroll click and I can enable this. All right, so let's just take a look at this really quickly. Yes, I have 3D printed some of these and I can show you. Give me a minute. Okay, so now we're turning this into a mesh to now put into, we're gonna bring this into Blender. So one thing that I noticed, I don't know if it's like a memory consolidation thing or something with Grasshopper, but if you have a large sub D with a lot of faces, at a certain point, it doesn't subdivide it anymore. Doesn't further subdivide this into more mesh faces, and not really sure why exactly it wants to do that to me, but one way around this is this sub D object. We can actually divide it, subdivide it again in Rhino, and then get more subdivision, because I want this to be a higher level of subdivision just so we can, it's more smooth when we render it. We spend all this time to make something smooth, and then we output it as faceted. It almost defeats the purpose of making it smooth to begin with. So I'm just going to subdivide this. If you ever kind of encounter this, you don't always need to do this. If it's a level of detail thing. Like if your level of detail, like if you had half the dimension, like the one that I showed you in the rendering here, I didn't actually subdivide this one because I didn't need to. I just used the default, like what it was getting for Grasshopper. So one thing that, it subdivided this, so it probably now it's taking longer in my Grasshopper document. So let me click that, right. So I'm going to go to Grasshopper. You can see now it's much more subdivided. I could try to weld it. I don't think I need to. It's going to take a second. It also didn't even work. So, all right, forget welding. We don't need to weld it. So we have that. So actually in this example file, there is a final export mesh here. So I'm going to bake things to this final export mesh layer. So one thing that I did is I also gave it materials, because one thing going into Blender, what it'll do is you can group it by material, and then that will be how you kind of isolate the layer in Blender. So it has a material associated to it, has names to it. So that's how we're going to group it. So I'm going to take this mesh from our sub D. Yeah, when it's like subdivided, sub D in Grasshopper is like super inefficient too. So that's just something to keep in mind when you're working with sub D. Okay, so let me go ahead and bake this into my tessellated mesh layer. That's the one that I want to bake that to. The nice thing about meshes in Rhino is they're pretty lightweight, so it's not going to cause like a huge file really. One thing I kind of noticed is like this is overlapping little bit here. And that's also a resolution level of detail thing. So one thing that I could do is right now I'm offsetting this by a factor of 0.125 meters. So what I could do is I could actually copy that and not have this create solid checked, so it doesn't create a solid. And maybe I want to give this another much smaller factor here. So 0.05, let's just see what this does. Then I offset that mesh and that'll pull that away, right? So it's not like intersecting ourselves here. So yeah, it'll just pull this off of here a little bit and give us some breathing room here. Yeah, maybe a point like 0.075. Right. So yeah, you just, if you see something like that happen, like this is another little trick that you can deploy here. And I'm just offsetting it first by a set number, so that's kind of pulling it away from my my pattern mesh, and then I'm offsetting that to give it some thickness. Right, so that gives us some nice thickness here. Okay, so I'm gonna bake that. I'm gonna take this and I'm gonna bake that to in my final export meshes. I'm gonna do that to minimal surface thickened mesh. And I'm gonna press OK. I'm just gonna go ahead and save over that. And then I'm gonna disable this again, just so that can take a minute to import. So yeah, this is going to be the geometry that we're going to carry into Blender and render in Blender with. Okay, give me 1 minute and let me share. I'll share a 3D print. I'll just show you. Okay, so a 3D print I did, blurring my background. Second. Okay. So this was a mesh network that I 3D printed. This was one I printed while I was at INEAD Architects. Using, I mean, this is using like several types of triply periodic minimal surfaces kind of strung together in a network. And then I use these same techniques to print this. So this is a fused filament deposition print printed on Ultimakers. So pretty kind of standard printer. Yeah, so this was printed on an Ultimaker 3D printer. So this is, yeah, this was running through the process of what I was doing for the continuous formations, like everything that we've done. And then I think one difference is I started with this one as a minimal surface. So I went from a minimal surface and then used the technique. I just trimmed it. But yeah, essentially it's the same kind of concept to get this this shape. So yeah, this is ones that I printed. This print probably took several days. I think this took 4 to 5 days to print actually. This one probably took a similar amount of time. Thank you. To use clay, I think you would have to experiment. Clay's tough because you need the build support for this type of print. I mean, you could conceivably design it in a way to where like build support was less needed, but that's something, you know, I think it definitely has to go through the rigor of designing it and figuring that out. Now, some people with clay, they can like artificially put building support, like some scaffolding up, like that's something that you could potentially do. So if you have a process for that, then yeah, I think, you know, anything is possible. It just takes a lot of experimentation. Cool. I'm just gonna stop my video. All right. 1 second. Andrew, to answer you, the surface texture on those prints are smooth. So no, those don't have a surface texture. I have printed them with surface textures before. Okay, one more show and tell, and then we have to get to Blender. So this is one with a surface texture. Basically, the process is you do the texture on one mesh, then you offset the smooth part of the other mesh, and then you basically match it so that the edge conditions or the subdivisions are the exact same from the smooth mesh to the textured mesh. And then you can do a mesh loft like the ones that we did here to create the lofting. So that's kind of the process if you're trying to 3D print something where you have a texture on one side and then you have a smooth condition on the other side. That's how you do it. So, I mean, the texture could be whatever you want. I've actually printed a lot of things with textures like that. So yeah, you can totally do that. Okay, so yes, now we are to Blender. Okay. So we don't need Grasshopper anymore. I'm gonna just take these and close out. Okay, so the process to go into Blender, I'm gonna export this. So I'm just gonna export these two meshes all as one. So we've created our meshes. And now what I wanna do is just select both of them, and I'm gonna go to File, and I'm going to export selected. Okay, so I'm exporting selected. I'm gonna just export this to the share file folder. So the type of file that I want to export here is I want to export an OBJ file. So OBJ is right here. obj.obj, file name, continuous formations, mesh to a Blender example 1. Okay, so OBJ, I'm going to save this here and just press save on that. And then some options here will appear. So basically for the options, I'm just going to go through each one of these sections and show you the options that I have are correct. So polygon mesh object, we've already converted it to a mesh. Windows CRLF, that should be by default. So what you want to do is you want to export material definitions, use display color for objects with no material set. That's fine. Map Rhino Z to OBJY. You can leave that checked or check it if it's not checked. The rest of these, just make sure that these two are checked and that's checked and these are unchecked. Naming. So do not export object names. That's fine. So what we want to export layer group names. So layers as OBJ groups. That's what we want. So I mean, basically it's going to be like the layers that we have. That's going to be how it's grouped by here. And yeah, you can sort those. That's fine. And then under mesh, we're just going to keep the mesh welding unmodified. We've already meshed it. We already basically have done everything that we want to do. So the other things, make sure that these things should be checked, but if they're not, make sure that they're checked for you the same way that they are here. So export texture coordinates, export vertex normals, and export open meshes. Yeah, so, and we actually just I wanted to have control, like we want to always have control over how we're sub-D, like turning our meshes from sub-D, from meshes or from sub-D to meshes. So like, I don't know. I don't like to mess around with this so much because I like to have control over it myself. And once I have those settings set, I'll press OK. Okay, and in our folder here. Cool. So still thinking a little bit. While that's thinking, I'm going to open up Blender. One thing that I love about Blender is how incredibly fast it is to open. So yeah, it's kind of amazing how fast it is. So once we're in Blender, we can go ahead and delete our default cube. That's just the trick of the trade. So Blender, you open it. Yeah, I just type in and I open Blender. It's a little different than Rhino. So you pan around with your scroll wheel with your middle mouse. That's pan. You're not right clicking. Zooming in and out is the same with your scroll wheel. But rotating is with your middle scroll wheel. So this is how I'm rotating. If I hold shift, I can pan. So that's going to pan for us. Right now we're in object mode in our layout. That's fine. So one thing, I guess the first thing that we can do is we can go ahead and go to file and we can import the geometry we just exported. So I'm going to go to file, go to import, and I'm going to go to wavefront.obj. So that's going to be our OBJ file. So it's a wavefront file. Okay, so it's not going to direct. Yeah, this folder structure could probably be improved on Blender, but this is what we have to work with. Let me just make sure that this is saved. Okay, so we're good from Rhino. And what I'm going to do is I'm going to just copy the folder link. So wherever you have this saved, whatever folder you're working out of, I just copy the link and paste it into here and press enter and then find my link that way. So I don't care about this material object. That's, really just for kind of helping us group things. I'm going to click my .obj. That's all I need. And one more thing to think about. So forward, -z, forward, up, y equal up. That's what you want. I think that's the default. Just don't mess with that. And then for geometry, this is very important. I wish they didn't hide it like this, but before you hit import, it is super important that you just click this geometry tab. And by default, it's splitting by object. Well, by object isn't going to help us because as far as the OBJ is concerned, it's actually grouped. So it's going to not split by object the way that you think about it. What you have to do is split by group. And from our export settings from Rhino, we have created these groups for us to split the geometry and come in separately. So make sure that you check split by group and then import your OBJ. So this might take a second to import. Oh, and Kareem, to answer your question, yes, I did print some of those. I printed the continuous formation looking ones with support. The other one with the texture, I did not use support. And yes, Blender is a free software. So one thing that's great about Blender is it's completely free and it's open source. Okay. So here is our geometry. So it's going to come in large because we've used some working in large groups of meters. So that's fine. Okay, so a couple things that we want to do. Since we're rendering, I can go to my rendered viewport, which is here. So if I'm up here, or rendered display mode, sorry. So viewport shading, so you can look at shaded view, you can look at material view. That's just going to show you the kind of your textures and materials without light and shadow. And then you can look at the rendered viewport. So by default, Blender puts a light in the scene, and then it puts a camera in the scene. So if I want to move any geometry around on the side here, I have options for that. So I can use the move toggle here, and that's going to give me a gumball situation where I can take this light and I can actually move it closer to my object. So, I can start to light this thing. So let's start this by looking at the light. So if I select a light here, I can go to my light options, and this is a point light. You can change it to things like a sunlight. It's going to make it like an intense sun. You can change it to a spotlight or an area light. For this, let's keep it as a point light. The color, I'm just going to keep this to a white light, how it exists here. If I want this to be brighter light, the default value is 1000 watts. Well, I can change this. I can add a 0 to that to 10,000, and that's going to now create a much brighter light in my scene. So other things that we can do is we can change the radius of the light. So what that's going to do is the smaller the radius, the kind of more extreme the light will be. And the larger it is, the softer the light will be. So if I change this to a larger value, like 20 meters, right, the light you can see is already getting softer on our screen. If I change this to something like 10, right, it's going to be little harsher than it was, but still softer than at 0.1. So yeah, this is a variable that you can play with like a slider. This is as well, like I could change this to 20 and make it like very bright in that spot. Another thing that you can do is you can hit Shift D and that duplicates the light. So if I want to make a copy of that light and drag it around, I can do that. So it's going to make another version of this light to add to our scene. So if we want like a couple spots of light coming from, and maybe I want this to be a brighter light and I want this to be a softer light, you know, I could set this down to something like 6,000 watts and make that a softer light, and even increase this radius a little bit. So that's a softer light coming in my geometry. So yeah, this can be the brighter light. So right now by default in our render view, let's talk about rendering settings for a second, because this is going to be super important. The output properties is going to be the resolution of your camera, like what it renders, but the render properties here is where you set what rendering engine. So by default, it uses a render engine Eevee. So Eevee is basically a real-time render engine for Blender. So it allows you to render things in real time. So as we're panning around, right, this is going to be more like Blender's version of Inkscape. It allows you to, you know, operate real time and render without, you know, taking a considerable amount of time to render. The downside is it's not as accurate. So like this is going to be more like your Inkscape type of render, your twin motion type of render. But, you know, because it's real time, it's kind of approximating the light and the shadows. It's not actually giving you an accurate representation of light and shadow. So to do that, we need to switch the rendering engine to cycles. So cycles is going to give us accurate lighting and accurate shadow and bouncing. And, you know, if you're doing kind of if you want a high quality render, cycles is what you'll need to be using. I mean, you can get good options with Eevee as well, but, you know, it's a bit of a different process and it just depends on what your needs are. For this, I'm going to be using cycles. Since all we're trying to do is get still images off of this, cycles will be perfectly, but cycles is what you want. So the next thing that we want to do is let's just go down our settings. So these are things that'll kind of optimize what we're doing. So if I was trying to render something with CPU, well, the CPU is extremely slow when you're trying to render. So what I want to do is I want to change this to GPU compute. I want to use my graphics card. And already that's going to be much faster for me to pan around the viewport because it's using my graphics card instead of my CPU, which my CPU is already being pretty loaded by all these processes of running the software. I want my graphics card to really take the brunt of computing the rendering. Okay, so this gives you various settings in the render settings. So one thing that I do is I go to sampling and I set up there's a viewport noise threshold, and in render, I also give this a noise threshold. I think 0.01 should be adequate. Like it's something you can play around with, but really what this threshold will do is, like without kind of explaining it in detail, it'll just make your rendering go a little bit faster. Another thing that is kind of essential is denoising. So I use the denoiser. I think you can probably do automatic, but you can also use optics, or you can use open image. I'm going to set this to optics and use the optics denoiser. But yeah, denoising, you're going to want denoising because if you don't have denoising, right, you can already see that in the viewport, it's taking the noise. So if I don't have that in the viewport, you see how it's kind of grainy here. That graininess will show up in your rendering. So this is for the viewport. You see how now it's kind of like smoothing it out. So when I pan around here, it's smoothing out my view here. So just make sure that the denoiser is actually also in your rendering. So I guess in my rendering, I have open image denoiser selected. Maybe optics is a little brute force. I don't know. It's something you have to play with, to be honest. I think you just kind of play if there's one denoiser you like better than another, but definitely have denoise on. I mean, it'll actually add a little time to renderings, but it'll make your rendering not look crappy. So denoise is pretty important for just making good looking quality renders. Okay, so that's kind of like my viewport settings. So in render, I have the noise threshold, I have denoise set up. So I can click off that. Light paths, I don't really mess around with that unless doing something specific. So another thing that I like to do is I simplify my rendering. So the max subdivision by default is at 6. I think you can lower this by quite a bit. If I set that to 2 in my render, so you could even set it to 2, it'll make the rendering go quite a bit faster. So yeah, I'm just going to set that to 2 and leave it there. So I'm going to simplify my rendering. I think for everything else, the last thing is, you can give it a transparent. So let's set up our camera real quick, and then I'll come back to this. Okay, so the camera, I can get into the camera. So you can move the camera around. I can move the camera just the way that I move the lights. So I can actually drag the camera over here and look at it this way. But if you click this little camera button, you can toggle the camera view. So now I'm in the camera view. And if you're like me and you're a predominant Rhino user, well, you like to be able to see the camera when you're panning around, but in Blender, that's not automatically the setting. So if I pan out of the camera, right, it takes me away from the camera view. So the thing that I can do is I can actually go here to view, and then I can check this box, camera to view. So if I set this, I basically just hit this tab here for options, and then I went down to view, and I'm going to check on camera to view. And what that's going to do is that's allowing me to, if I pan around, I can use the camera actually to look at my object. So a couple things, you can change things about the camera here. Like I can change the angle. I can turn this into like a 18 super wide angle. I can change it to more of a narrow lens, like 70 mil. So if you're into photography, the focal length, that's going to be like the focal length that you would shoot photography with. There's other things. One thing that I like to do is set up, I mean, you can do depth of field and stuff. I'm not going to get into that, but where is it? Viewport display. One thing I like to do is use under viewport display the composition guides. You could set it up. I like to use thirds. It just kind of depends on compositionally what you're trying to do. We'll keep it simple with thirds. So right now the camera, it's displayed to exactly the dimensions that it's set here. So if I go into my output property, this means that the output of my rendering is going to be the X and Y resolution here. So if I want this to be, this is kind of a vertical object. So if I want this to be more vertical, I could do like an 8:10 aspect ratio. So 800 by, I could just do 1000. And that's going to give me an 8:10. So you can post it nice to Instagram. And so the rest of it is just kind of composing your image. So you can keep that checked for a moment just to see where you want to render this from and find a view that you like. So I don't know, something like that is pretty good. This is another thing that you can spend a lot of time playing around with. So yes, you can change the background color. I'll show you that. That's the next move here. Okay, so I've done that. I've set my camera. I've set this resolution. It's 800 by 1000. So once I have my camera ready, I like this. This is the view that I want. I'm gonna go ahead and uncheck camera to view because I don't want to move it again. So this is now gonna lock the camera. So if I pan around, it's now locked. And then I can click this camera again to toggle back to my camera view. Okay, so the background is actually in this world setting here. So you can go to world properties and you can change it to whatever color you want. But keep in mind, that's going to also have an impact on your lighting and shading and shadow. So I like to keep this pretty dark. You can darken it, like you can go to all the way black. It just kind of depends on what look you're going for. Maybe I don't want to keep it like completely black, and I can kind of control the rest of these settings in Photoshop, right? So I'm going to do that. And I don't want it to render with the background. If I rendered this right now, I could render my image. I'm just hitting render. I'm going to the render tab and then hitting render. Okay, so this is rendering it. And the problem with this is it's going to keep that background, and it's like a gray background. So I don't want that actually. So let me just close out of that. It'll also help you with time. So this is where, if I go back to my render properties again, so I said I would come back to film. Film, you can go ahead and hit transparent. So to answer Yakin, the rendering with an alpha channel, yes, you can. But to get like channels for materials and stuff, I would say, I think there's ways to do it with compositing in Blender, but it's kind of advanced. Like it's a little more of a process to set that up. Unfortunately, I'd say that's probably rendering in Blender's greatest weakness. Now, I love Blender. It's free. You can do a lot of amazing things with Blender, but the kind of setting up like material channels is, I haven't figured out like the best way to do it yet. And I'd say that's probably its weakness. So, okay, right now I've turned in film, I've turned this to transparent. So that's, now when I render this, I can render the image, and it's going to always remove the background when I render it. So this is just going to be a nice clean, if I save the file, it'll be a clean PNG that doesn't have any background to it. And that's exactly what we want. So I think now we've our settings dialed in. We've set up lights. We've set our camera up. So the last step we need to do is go to materials. Yep, so I'm about to show you materials. You are all a step ahead of me. So yeah, the materials is really the kind of last portion that we'll show here. So if you click your object, so any object, now you have a few more options here. So you have different modifiers, things like that. You have object data property, and you have material property. So material is going to be this property down here, and that's what we want to look at. So you can change the colors and things. Like I can turn this into a pink material if I want. You can use like subsurface scattering. What that does is, which I kind of recommend playing with that on your own. But like if you turn that up, it kind of creates it's kind of like how flesh works. Like if you shine light through your hand, you can see that it's kind of translucent. It doesn't, like your skin isn't totally opaque. you can see things kind of light bouncing off the material of your fingers, or really anything. Like if you look at your earlobe bouncing in the light, like you can kind of see through it, and it makes like, you can see light kind of bouncing around because the material of your skin is not completely opaque. So subsurface scattering is basically like doing that. So you can get some interesting things by playing with subsurface scattering. Other things, like you can make things metallic, specular, all of that. Like I'm not going to get into all of that stuff right now. Well, I'm glad you're excited. Yes. So cool. So what I want to do is I want to create kind of, if I look back here, I want to create materials like this. Like I don't want it to be just a color. I want to give it some pattern, some definition, and I want to do this procedurally. So that's what we're about to do. And the last step is to set up some procedural materials using Blender's material editor, which is here under shading. So one thing that I can do, I can go to my shading tab at the top. So yeah, you can always use the material editor here, but the real power of it is this material node editor here. So like you can do a lot of cool stuff with this. And this is like a kind of Grasshopper interface for materials in Blender. So yeah, this is found in the shading tab here. So I can click my camera and kind of go to where my object is. I can zoom in, I can zoom out. I can pan around my object as well. So yeah, I'm gonna just zoom in on my object. So right now I have this. Okay, so let me click the pink one. So I'm gonna do the pink one first for a second. So one thing that I wanna do is with this is, before we get into editing anything, go to edit at the top and go to preferences. And okay, sorry. I left out something very important when we were setting up the render settings. Before we do anything, you want to come here and you want to go to system. And when I went to, you know how I changed from CPU to GPU compute, one last thing that you want to do is you want to make sure that your graphics card is checked. So if just your CPU is checked, you can also check your CPU. I just would caution you, I'm not going to turn this on because what will happen is if you check the CPU, it's going to devote energy to rendering on your CPU. And like, I couldn't really host this Zoom call the same way. Things might cut out. So because a lot of my CPU power is going to be going to the rendering. So I'm just going to uncheck that for this. If you're not trying to do anything in the background and you're just rendering it, then like it'll help you take some time out if you have this checked. So I'm keeping it unchecked, but just make sure that in the system, your graphics card is checked here for CUDA, optics. I think it depends on if you have an AMD graphics card, something else shows up. I'm using NVIDIA. So, I mean, I think you'll figure that out if you don't have NVIDIA. So yeah, it's crucial to have your graphics card checked. Okay, so while we're in preferences, and this is related now back to our materials, we can go to add-ons. So this is another awesome thing about Blender. Like Grasshopper, independent people and developers have developed plugins, just like how Grasshopper people develop plugins. And anything that is been tested, it's kind of like, this is like Rhino, the Rhino, what's it called? The package manager. Yeah. So this is basically like a package manager for Blender. But the add-on that we want is, we want this add-on called Node Wrangler. So if I type in Node Wrangler into the search, this will show up. Make sure that is checked. So just make sure Node Wrangler is checked. I'm in the Blender preferences. I got here through edit preferences. Just check that. That's fine. And then I can check out of that. So what's going to happen with that is I can press Control T here. And now what that's going to do, so this is just because it's a shortcut. So Control T, if you select any objects, it'll just give you the kind of like mapping that you need to make textures. So right now, this is giving you the option to use an image texture. So if you have image textures from online or wherever, like somewhere that you have a texture, you can put that texture here and use that as our texture. I'm not going to do that. I'm going to delete that because we're going to use a procedural texture, which is much more fun. Okay, so under mapping, one important thing is right now we're using UV mapping. So because I'm bringing this in from Rhino, this has all been, designed from a Rhino model. I didn't do any UV mapping or anything complex like that. I'm just going to use the object. So I'm going to take the object map here and plug that into vector instead of UV, just because we don't have any UV maps for this. That's a whole process. We're not going to get into that. We don't need to get into that. I think you can just use the object button there, and that's fine. So to add a material, we'll shift add, I want to add a procedural material or procedural texture to this, and I plug it in from my vector to my base color. So the way that I'm going to do that is I press Shift and I press A. A is for add. So Shift A, and it'll give you this kind of option. So we can search for things, or we can just go to texture here and we can look for a texture. So the texture that I'm going to start off with, I'm going to use this noise texture. So I'm going to plug noise texture into my vector here. And I'm going to I can use the color. So color is going to give us like this multi-rainbow color, right, as we see here. I'm just going to use the factor because I don't care really what the color is. So this gives you a few options. It gives you some other drop downs. We can keep this like this, but you can change the scaling. The higher the number, the more dense your material pattern is. So I can change it to more or less dense. Detail is going to kind of add a detailed expression there. Roughness is going to make it more rough. So right now it's kind of hard to see, and distortion will distort it. We'll look at distortion in a second. But one other thing that I want to do is you can kind of control the colors of these materials through something called sorry, I just want to be able to pan around this, and sometimes it's finicky. Anyway, okay, I'll just do this. I want to be able to control that color here. So I'm going to do Shift A, and I'm going to just search for this, and I'm going to get a color ramp. So before I click in here, one thing that's cool about Blender's node editor is that if I click between a thing that's plugged into one thing to another thing, if I just drop that here, it's going to automatically connect those things. So that's kind of a fun thing that Blender does. And I can use this color ramp actually to kind of change and control what these base colors are like. So what's cool about this is I can just procedurally change that based on kind of a color ramp. So it's basically changing the values of our texture. So right now it's at a large scale. So this will allow us to see this a little bit better. Smaller scale. Changing the detail is adding kind of how fine, right? So if we have a low detail, it's going to be a much lower type of pattern. If we have a higher detail, right, it's going to be more refined, more cloud-like. So roughness is going to also add like how rough this patterning is. So it's 1 versus low roughness, right? So you can play with these parameters. And a cool thing, distortion kind of allows this thing to swirl a little bit. So you can get some really interesting types of patterns this way. All right, so that's using this color ramp. So I'm just going to change this to 0 for this. Okay, So this is changing the color. One thing to change the actual color, like if I want this color to be something else, like instead of black, I can change this. You just click it and then hit this color thing here. And now you can change the value of the colors. So I can change this to something that's lighter, and I can give this like more of a pink texture or something, or blue, or whatever you want it to be. One thing to keep in mind is saturation goes a long way. Like you don't necessarily need to saturate it a lot. Yeah, maybe I want this to be kind of dark and a little bit pink, and maybe I want this to be like a very subtle light pink. Yeah, it's a little lighter. I mean, you can play with this forever, right? Like some of this is just playing around with the settings. So we can play and, give it different values, change the detail, right? So one cool other thing that we can do is right now this is like totally smooth. I think the last thing is we can give this a bump. So I can come here and give this let me just search for bump. So we're going to get a texture called bump here. And I can just plug the color from the color ramp into my height. So I don't need to do anything else. I just want to change that height value. And where it says normal, so I don't need to do anything for the normal here. Where it says normal, I can plug normal into the normal map here. All right, so we can already see now that's giving us a texture based on our noise. So like this is now giving us a rough texture, and we can change the strength of that if we want it to not be as bumpy. You could change the distance to really kind of crank up the strength. It's somewhat related to strength. A zero distance will be smooth, and then 1 is going to be a higher distance, but probably just play with the strength. So one cool thing that we can do is we could have a noise texture really playing with the bump. There's other types of textures. So if I go to Shift Add to Texture, like a lot of these textures are cool kind of procedural textures you can use. So Musgrave texture is another interesting one. So actually to get this rendering, to get this kind of pattern, I used a Musgrave texture. So I can plug the vector there into that. I can Control C and Control V. So if I want this color ramp for this, so I could make the bump related to a noise. So it could be like a rocky stone type of texture. But then I can use this to actually play with the color. Oops. All right, so now we can kind of look at what this is doing with the Musgrave texture. So there's some similarities to noise. One thing that I think I used a multifractal. So I just hit this and, okay, so let's see what this can do. .5. Raise this. Anyway. Something to play with. All right, so maybe. Oh, you can play around with it. See, I got something pretty interesting just by those settings. So yeah, maybe that's something. Anyway, it's worth exploring these various techniques. I'll just open this file to be honest, so you can look at it. That's the file I used. If I click on if I go to shading, all right, so these are the settings. So I used a ridged multifractal, okay, with a high gain, lower offset. Let's see if I can try to replicate this on this geometry. And honestly, a lot of this, I just play around with these settings and find something that I'm interested in doing. So if this is like, that's where I had this at 0.45, this was at like 13. And these were flipped, so let's see if that matters here. 0.1. Oh yeah, so that's like a super high scale for this. There we go. All right, that's a little more like it. So sometimes just playing around with the settings in Blender will get you, you know, get you pretty far. You need to play with it a lot. So yeah, I mean, these are the settings that I'm using here for this. So I get this much kind of like varied, interesting fractal shape here. I think changing this around, right, gets you different. Changing the offset will get you something different. You know, it's, I think for this particular pattern, it's a little finicky to get how you want it, but yeah, changing the scale, you're going to get different, kind of a different variety. So yeah, one last thing is if I want to kind of mix the texture of my color ramp to my bump or my noise texture, you can actually shift add and I can do a what's called a mix RGB. So I can mix the colors from my Musgrave texture. I can mix those colors to my noise texture. Maybe I don't want to mix that for the base colors, but I can use those values as my height value for my bump map. So now I have a bump map that is related to both my noise texture and my Musgrave texture. So what I can do is, you can change the factor. So factor of 0 is going to be all color 1. So that's going to be entirely the Musgrave texture as your bump map. Or if you do all 1, that's going to be entirely your noise texture. So yeah, if you leave it around 0.5, it's going to kind of evenly mix that. And you can change the factor of your noise. There's also things like you could also mix the bump. You could do it you can get as complex as really you want to get. So maybe this gets shallower. All right, what I like about this Musgrave fractal texture is you get these kind of interesting swirly patterns. And what I like is it's also entirely procedural. So you just kind of adjust the sliders and it's going to, create these patterns along my surface. So that's that texture. And so let's just take a look really quick at this other blue texture. One thing that I can do is I can use the node wrangler, press Control T again. So I'm going to now go turn my object into vector. I'm going to take the image map and delete that. And maybe for texture, let's use a Voronoi texture. So I'll use a Voronoi 3D, and I'm going to use smooth F1 for this. I'm going to plug vector into vector. I'm going to get a color ramp, just like what I did before. And I'm going to change maybe this. Maybe I'll leave that at white and change this to like a subtle. Oops. Okay, that's fine. And change this to brighten that, change it more blue, maybe darken that slightly. So Voronoi, I'm going to use the distance for this factor actually, and then plug that into my base color. So the cool thing about the Voronoi is you can, give it this kind of texture. You can change the smoothness. So if you change the smoothness all the way down, and let me just do this real quick, then it's going to give you much more of a, if I darken that, like a much more of a true Voronoi, but it's still smoothing it a little bit. You can also change the randomness of that. So you can get it much more grid-like if you change the randomness all the way down. But if you crank that all the way up, then it's going to make it very random. So smoothness, I'm just going to keep that all the way and, kind of adjust this as I want. So that's going to give me kind of that textured pattern. And just like we did before, we can use this as the bump map. So I can Shift A and then add a bump. Color is going to go to height, and then normal is going to go to my normal. So now that's going to give me a height definition based off my Voronoi and color ramp, which is fairly interesting. You can change the strength if you want, so it's not as intense, or you can leave that up. And now we've set procedural materials using Blender. Maybe this, I don't want that to be so dark, so I can lighten that up and just make that kind of subtle. So yeah, let me save this file. So I'll save to continuous formations, share files. So I'll save this as Blender sample rendering and save this file. So now, all you do is you render the image, and we've already set up the settings, and we can render it. Yeah, thanks to everyone who's stuck around with us over the time. I know this went pretty far over the session minutes, but that's okay. There's a lot of important stuff to look at. Where's my rendering? Okay. I thought I hit render. All right, so now we've got that, and we can render this out. So, right now, this isn't like a super great rendering yet. It's fine. But one thing that you can just make it better, I'm not going to do this, but one thing that I do is I'll set this number to a higher number, like 300 or 400. So you can change this percentage value, so you can keep your resolution the same. If I wanted to render this at a much higher quality, I would change this to something like 400. So when I rendered this image, that's what I did. So that's how I can zoom in on it, and you can see like pretty high level of detail from zooming in. If you don't do that, if you don't have as high of a resolution, it's going to look much more pixelated if you try to zoom in. So that's really just, I think, the last point I'll make about the rendering. And really the last thing that I can show you real quick, and I'll just show you with a file that I already had, is I use Photoshop to, whoops, that far back. So I'll save it as a base image. So this was the base image. So if this was my the image that I was showing, this image was actually the rendered output from Blender. So what I do is I basically just put this into Photoshop and just add a few tweaks to it. So I can just open the Photoshop file for this and show it with this example. So yeah, I mean, the pipeline, we're using Rhino, Grasshopper, using these techniques, and then taking that to Blender to render, and then Photoshop is kind of the final step. So yeah, I might have some background layers that I'm playing around with. I ended up going with pink in this case. Blue is kind of nice too. Black is also, just kind of depends on what you want to do. The nice thing is, when I turn the background off in Blender, is it gives us a PNG, so we don't need to like isolate the background. We can just have whatever background you want. So yeah, I mean, what I do is, if this was my image, I just right click it and I turn it into a smart object. So I've already done that, but if I was to take my PNG and put it in here, I just say convert to smart object. And what that'll allow me to do is I can have smart filters. So if I turn the filter off, this is what the base render looks like, right? But I use the camera raw filter to just like tweak the settings, basically. I mean, you can also do levels. You can change the levels. Let me do clipping mask, actually. Clipping mask. So, I mean, the levels are kind of nice because you can just change the light quality right away. But a thing that you can do with camera raw is you can even adjust the colors. You can change the sharpening. So yeah, I mean, what I'll do basically, so I'll add another one. I'll go to filter. Maybe I'll use the camera raw filter here. Oh, and so it's compounding it because I already used a camera raw. So let me just hit cancel here. One thing, okay, I can just double click this and go into my camera raw filter. Yeah, so it'll give me this. It'll allow me to zoom in to see the detail, zoom out to see it, what it looks like globally. I usually don't touch the temperature much. I might change the exposure ever so slightly. I'll change the contrast. Yeah, so you can like play around with these and see what, kinds of parameters you like. I'll up the highlights, decrease the shadows, change the blacks. Sometimes I adjust the vibrance, sometimes I adjust the saturation. Maybe you want this to be hyper saturated, maybe you don't. Like you can change the saturation here, right? It's kind of up to you on and what you want to do with it. But yeah, I mean, this is really like the last step. It's kind of like the artistic step that gets you to like really finish up the nice details of what you want. So yeah, I mean, the camera raw is like an amazing filter to kind of do this stuff and have some great control over it. Oops. Another thing I do is I look at the detail. So I actually have the sharpening just for this because we're dealing with like sharp textures and stuff that I want to see. So I'll bump the sharpening up and maybe I'll do noise reduction. Like the more noise reduction you have, the more smoothed out it will be, right? Like it just kind of depends. I wanted to show, we spent all that time like developing noise details. So I want to keep some of that at least. If you don't have any sharpening or any noise reduction, sometimes the sharpening, it looks a little messy. Like it could add grain to it. So you kind of work the balance of sharpening and noise reduction, right? And you kind of get it to a point where you want, like this was, I liked this when I was playing with it. You could also do the color mixer, which is cool. Like sometimes if I, whatever the base colors I used for rendering, like sometimes I want to mess with the colors. Maybe I want that to be more red or more purple, right? Or maybe I want the blue to be more purple, right? Like or more cyan. I don't know. Like you can play around with the colors as well. So I mean, this is like the amazing thing. At cancel, yes. So leave it to where I was, and yeah, this is basically the process. That's the workflow. Two-sided materials, yes, I think so. But I think the way that you do two-sided materials is you just treat it as separate meshes. So you would say like on one direction is going to be one material, the other is going to be another material. Awesome. So yeah, I appreciate everyone.
Hey, that's
Hey.
awesome. Very detailed. It's good to like go in depth in those things, especially a lot of the mesh stuff, gets gets overlooked often.
That's true.
All the little tiny things, that need to be carefully like checked out and very good to see.
Absolutely.
Does anyone have any questions? Or did you answer this big one already? I don't remember.
Sorry, I haven't had a chance to read. I'm reading it right now. Sent me a doozy. I mean, yeah, you can reach out to me. My time is very limited these days, but I can try to help any way I can. Yeah, you can probably send me an Instagram message. I should probably go through and check my. I haven't checked my requests in a while from people I don't follow, but
All right, so yeah, you can.
oh, the 3D print. I used the Ultimaker 3D printer for the 3D prints that I did. Oh, to duplicate the light, you just hit Shift D. Shift D with it selected and it'll duplicate. Yep, you got it.
Okay. Anyone else have any questions, or does anyone want to ask a question? If anyone wants to ask a question on camera or microphone, you can raise your hand and we can bring you, or you can ask a question in Q&A. But it seems you answered a lot of them as you were going, so it's good.
Yeah, I was trying to keep up with them.
Well, yeah, I guess if there's no more questions, we can just end it. It was, yeah, bit longer than planned, but that's always good to get more information. So I think everyone appreciates that. To not skip over the details. That's good.
Leave anything out?
Yeah, yeah. Cool. Well, thank you. Oh, here's some stuff. Sorry, Shake. I already answered you about that. This webinar isn't about that. You can reach Ayub if you want to message him. Yeah, I don't know anything about that, and I don't think Alan would either. So
Never heard of that. The penalization command is not working. Don't know why that would not be working. Is it are you using the Grasshopper file that I was sharing and it's not working?
check out pieces of something.
Oh, in Blender, to get back to the main view, you just, the tabs at the top, you click layout. So there's layout, modeling, sculpting, UV editing, and then shading. Just go to the layout tab. Yeah, I mean, I don't know how to answer this other one without seeing the file, to be honest.
Yeah, I mean, you could always come. If you raise your hand, we can bring you on camera if you want to share your camera. I don't know. That's really going to be the only way to be able to help you. So if you want to share your screen, just raise your hand with the raise hand button.
Yeah.
That would be the only way to be able to help you with that.
Okay. Thank you.
Bring them here.
Well, all the files are already shared in I shared the link. Do you have access to the link?
Yeah, they'll have it.
Okay. It's in the link. Oh. Ignacio, looks like you're missing some components. Are you using Rhino 7?
Actually, you got to turn on your microphone. We can't hear you. Yeah, there you go. Still can't hear you.
You're hard to hear.
Yeah. Rhino 7.
Yeah, I'm using 7.
You're missing components, so that means
Is
you're
the-
either missing a plugin.
It's
I
only
don't think
for this one.
I don't think that's a plugin, is it? That's the. So I'm using a plugin that I'm not aware of. So that is the sub-D vertices. Do you have the latest Rhino version installed? Remember those?
Maybe it's because of that, right? Maybe it's another version. Okay.
Those components are a little new. Like they didn't exist. They didn't exist. Like I think.
And it's possible to do it with this command, like to search here, like
yes.
where, so like here, no, like.
Oh yeah, that's an older version of it. So The icons they changed. Yeah, exactly.
Okay, okay.
I
I
think
was not
update.
sure what was this. Okay.
Yeah.
Which component is it?
It's the sub-D vertices.
Well, yeah.
So yeah, sub-D I'm like, yeah, under the sub-D tab, because even the sub-D edges, like the one that you're sharing on your screen, like I think you're using an older version because the icon is different than the icon that I have. I think that's all been updated recently.
Okay, okay, okay.
There's a new version, and I'm pretty sure this component's like pretty new.
Okay, I see. Okay, no problem.
Okay, cool.
Thank you, thank you. It was sorry, it was sorry. It was the only thing that it was not working in the file, so it was just like I want to make sure.
Right. Okay, awesome. Yeah, I think if you update, I think you're gonna have those components.
Okay, okay, sure, no problem. Thank you very much.
Awesome.
Thank you.
Thank you. Yeah.
But then I think if the Caviar wants to answer something. Oh, I think I got removed. One second, Alan. For some reason it jumped to you, so let me bring it back.
You booted me.
Yeah, it like switched your names around as I was clicking it. And
Yeah.
Yeah.
Cool. So I lost all those. The question got thrown in there. I lost them all.
oh, they should still be there if you open Q&A.
Nope, not they. Yeah, they all are gone. It's okay.
The questions from the chat or Q&A?
The chat's there. The Q&As, I think it wipes the slate because I just got on as a panelist.
Oh, there was, I can read it to you, but where's Caviar? He wanted to come on here. Let's see him here. What happened to him? Anyway, so how do you add custom designed textures to surfaces in specific desired pattern?
Specific desired pattern. So you're talking about Blender, I'm assuming. I think the way you probably do that, well, I mean, it just depends on what you mean by specific pattern. You could do an image, right? You could use an image texture for that. That's going to be much more specific, and you can tile it. Other procedurally, I mean, you can probably get one that has some more specificity than the noise. Because like I think the noise in the Vornoi I was using is a little like designed to be a little more random. So yeah, I think it just depends on what you mean by that.
Mathematical modeled ones like a result of simulation. I think you should just, yeah, like look up some advanced texturing or something like online, because I mean it's kind of too vague of a question that you're asking. It's just really depends like what you want to do. It's the answer could be endless. Just try to look on some like more advanced texturing tutorials and experiment a bit, and I'm sure you'll come up with something.
Yeah, I mean, and CFD is like a totally different animal.
Yeah,
that's
fluid dynamic. Yeah,
you have to go through, you know, the CFD engine basically. I mean, there's Dragonfly and Grasshopper that you could do CFD, or there's like other things, but you know, that's like, yeah, I think if you want to do fluid dynamics, you know, you just use a fluid dynamic software or use like the Grasshopper. I mean, it's kind of also a lot of things you can do.
When exporting mesh, what is better, OBJ or 3MF? How are they different?
I use I don't know. I use OBJ.
I don't even know what 3MF is.
Yeah, I've never used that, so I don't know.
Yeah, I don't know what that is. But, I mean, OBJ is pretty universal mesh. If you need like the advanced OBJ is FBX. If you need like a bunch of other information with the mesh, like layers and materials and all that kind of stuff.
Right. Yeah. If you're
I don't know what 3MF is though. Never heard of it. And Flo says, thanks, that was amazing.
All right, thank you. And thanks
Did anyone else want to ask? I saw a hand up here before and I don't know. How could recorded session, I'll just type the answer here because like it's in like 10,000 spots.
Yep.
Okay. So yeah, that's it. Thank you everyone who stayed for this whole time. And yeah, as always, doing it, recording as usual and all that fun stuff. Thank you very much, Alan, for your time on this Sunday.
Yeah, thank you.
Thank you everyone for joining. Appreciate it as always. Yeah. Cool.
Yeah.
Well, make sure you follow Alan on socials and put that there one more time. Put this download link one more time.
Awesome.
And that's it. Thank you, Alan. And until next time, we'll speak later.
Awesome. Appreciate it. Good to see
See
you.
everyone.
Everyone.